Hello students, good morning. Welcome to another video of Vedantu Karnataka. I am Catherine, your physics master teacher. Can you all quickly let me know if I'm audible and visible? Yes. Yeah, I think I am. Yes. Hi Shri. Where are the others? Quickly, all of you send the link to all your friends. Ask them to join. Today we'll be discussing all 2 markers, 3 markers, 5 markers, everything. Hello Zara. Movies covered. Hello, good morning. Hi, Amarnath. So, all my students who were there yesterday, they're all there here today. Very good, very good. Okay, we'll start in another 1 minute. So, did you all study yesterday? Roshan is back. Hi, Roshan. Good morning, Sri. Hi, Tarun. Sorry, Tanu. Hello. Where are the others? Yeah, all my students are here. Okay, so let's start. Let's not waste time. Students, this year, if you're looking for offline classes, we have, you know, we have it in Karnataka, in JP Nagar. So you can visit our JP Nagar office if you want offline classes. If you want online classes, we're all here for you. So we'll start with some fill in the blanks, some 1 markers, not a lot. How many? Some 40 of them. Quickly, in 10 minutes, we'll finish it and then we'll start with 2 markers and 3 markers. Are you all ready? If you are all ready, can you put some fire emojis in the chat? Yes? So I want you all to tell me the answers. Okay, let's start quickly. First question. The phenomenon in which light bends around sharp edges or obstacles is called. So for your exam, you have options, right? But now let's not do it with options. Quickly, anybody knows the answer? Yes, very good. The answer is diffraction. These can be MCQs as well, okay? They can just ask you these questions as MCQs as well, but I've just put it as fill in the blanks, that's all. Next question. A dash is a rotating arrow-like representation used for visualizing AC quantities. This is a little difficult. So the answer is a phasor. Okay. Next one is very easy. Quickly. The unit used to measure capacitance in SI unit is. Yes, what is the answer? Quickly. I think there is a lag in the chat. Yes, Zara, very good. Zara has answered. The unit to measure capacitance in SI is not able to see your answers. It is farad. Okay, next question. Inside a spherical charged conductor, the electric potential remains. What is the answer? So, question is electric potential. If it was electric charge, the answer would have been 0. But if it's electric potential, the answer is very good. Constant. Very good, Zara, Amarnath, Shri, Ghost 46. Very good. These could be MCQs as well. Okay, I've just put it as, fill in the blanks here because it's good to practice without options. Next question. The principle used in transformers for transferring energy between coils is. This I've taught you yesterday in yesterday's class. Quickly. Where are the answers? Yes, very good. Very good. Goes to Zara and Sri. Yes, Zara has given the explanation also. Electric field inside conductor is zero, but electric potential remains constant. Yes. Very good. Revamma Shivaramu. I hope I've pronounced your name correct. Constant is correct. Yes. Very good. Amarnath, it's mutual induction. Why did you remove it? It is mutual inductance or mutual induction. Okay. Next question. The ratio of flux linkage to current in a coil defines its yes, inductance. Next question. The charged particle in an alpha ray is essentially a. This also I taught you yesterday. Alpha particle is what? It is a helium nucleus. Yes? Okay, wonderful. Superb, superb. Next question. The pattern of alternating bright and dark bands behind an opaque object is due to, again, diffraction. Next. Dash is used to create high magnification images of tiny objects. Very easy. I'm sure all of you would have answered. Yes. Quickly, what is the answer? Very good. It's a microscope. Superb, superb. Superb, superb. Ma'am, please share PDF. I just started the class. You want PDF? You can attend the class. If you attend the class, I'll give you the PDF. Okay? Please mark your attendance by liking the video. Then I'll know you're there in the class. Okay, 10. When light interacts with matter, it behaves as if it is made out of energy packets called. Yeah. Tell me. Yes. Very good. It is photon. Photons. Or photon is enough, no? Yes. Photon. Next. The number of magnetic field lines crossing a closed surface always sums to 0. Which law is this? Yesterday we learnt this law. The number of magnetic field lines crossing a closed surface is. It also proves that magnetic monopoles don't exist. So I want you to comment the law. Next question. A molecule with built-in electric dipole moment is called. Which one? I'll give you two options. Polar, dipolar. Which one is it? Which one has a dipole moment, a permanent dipole moment? Yes. Polar molecules. Very good. Question number 30. A gold leaf electroscope is a device used to dash electric charge. Very easy. Detect. Now the option should have been here. A dash is used to, detect electric charge. That should have been the question. It's okay. Next question. In vacuum, the electrostatic force charges between is at its. The electrostatic force between charges is at its. In vacuum, it will be maximum because nothing else is interfering. Maximum. A device that stores electric charge is known as. A device that stores electric charge is known as superb capacitor. Very good. Good. Yes, Zara and Amarnath are giving me answers to all the questions. What about others? Others. Very good, Amarnath. It's not peak, it is, peak or maximum, yeah. If you have options, you can just choose from it. Then you will know which one to put first. F is equal to, which question is that, Zara? Next question, let me see. 16. The bending of light wave when passing. 16. There's so many questions on diffraction. This is again diffraction. The value of the energy band gap in insulators exceeds. This also, yesterday I've shown you on that picture. It's always greater than 3 electron volts. Light waves are proven to be transverse by the phenomena of, yes, polarization. Super good. A dash behaves as an insulator at absolute zero temperature. Which one? Yes. It is an intrinsic semiconductor. All this we discussed in yesterday's class. Intrinsic semiconductor. If it's extrinsic, you're adding impurities. Then it won't. But if it's an intrinsic, which is a pure semiconductor. One important characteristic of electric charge is its, you can write anything. It's conserved additive. It is quantized. I'll write quantization. Quantization. Yes, are you all getting all this? Okay, next. The direction of induced EMF is predicted by what law? Super Lenz law. Lenz's law. Next, the force between electric charge in vacuum is said to be maximum. The dash rule is based on the conservation of electric charge. Which one? Kirchhoff's current rule, KCL. Kirchhoff's current rule is based on the conservation of electric charge. Next, the dash moment of a dipole is the product of its charge and the distance between them. So P is equal to 2QA. What is P? It is the electric dipole moment. Okay. Electric field lines move outward from which charge? Is it positive or negative? Very good. It is positive. Superb, superb. A molecule with constant dipole moment is referred to as, again, repetition questions, will just move fast. Okay, 27. Dash effect is seen in superconductors when they exhibit perfect diamagnetism. I don't think you need that. The answer is Meissner effect, but just ignore that. Next question, 28. Are you all answering? The chat is too slow for me, so. Yes. Some of them are confused between polar and non-polar. Okay. Another 5 minutes, we'll finish this and start with questions. Don't worry. The dash of a current loop in a magnetic field increases with loop area. Torque. Very good. And a conductor with zero energy gap is conductor. What kind of a question is this? Electric field at the center of a charged spherical conductor is, yes, as I said earlier, electric potential is constant, electric field is zero. Dipole is formed by a set of equal and opposite charges. The working of an AC generator relies on the principle of electromagnetic induction. The separation area of a PN junction decreases when it is, very good, very good, superb, superb. It is forward bias. Super students, good, good, good. The dash velocity per unit electric field gives the mobility. Yeah, what is it? All of us know it's drift velocity. The susceptibility of a diamagnet is always negative. This also I told you to learn those 3 tables, right? Yeah. The charge of a photon is, it's neutral, so it's always zero. There's no charge. Nuclei with identical atoms but different mass number are termed as, yes, superb, isotopes. The intensity of bands in a diffraction pattern is usually, it's not equal. For diffraction, it is not equal. The power factor in a purely resistive AC circuit is, it should be 1. This is also there in my last class. A dash is a surface connecting point of equal phase in a wave. This is a wave front. Okay. So if you have so many waves and you connect all of them equally, then they're called wavefronts. Okay? Very good, very good. Very good, Shri, Amarnath, Zara. Nobody else was there. Tanu was also answering. Okay. Very good. Now let's move on to the much awaited 2 markers and 3 markers. So as I said, most of these we will have, the concepts we've discussed in the last class. Today I have made them into questions. Okay. So the possible 2 markers and 3 markers. So if they're not very different from last class, students, these are all the same chapters. Harish, what notes do you want, dear? Yesterday's PDF, did you get it? I have uploaded it in the Telegram channel. Vedantu Karnataka Telegram channel. Harish, did you get it? Yeah. So these electric charges and fields, the 2 markers and 3 markers, almost those questions we discussed last class. So I will just go fast with that. 3 properties of electric charge. What are they? You should tell me now. They are additive, they are conserved, they are quantized. Additive means you can add charges. Conserved means you cannot create or destroy charges. Quantization means the total charge is always an integral multiple of the basic charge, which is Q is equal to Ne. There's one more property that's given here. Like charges repel, unlike charges attract each other. But it's good if you can write any of these 3 properties. Okay? Those are the main important 3 properties. Yes. Okay, all of you got the PDF for yesterday's class. Very good. Now, today's class also I'll upload it in the same Vedantu Karnataka channel. Okay? Yeah. So, state and explain Coulomb's law in electrostatics. This also we discussed yesterday. So, quickly we'll go through. These are all 2 markers or 3 markers. Okay? Yeah. The electrostatic force between 2 point charge is directly proportional to the product. Yeah. F is directly proportional to the product of the charges. It is inversely proportional to the square of the distance between them. So, if these are the 2 charges, directly proportional to the product of Q1 and Q2, inversely proportional to the distance. Now, if you remove the proportionality, you put a constant. Constant is 1 by 4 pi epsilon naught. So, you will get F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Okay. Okay. Next question. Write Coulomb's law in vector form and explain the terms. So, what is Coulomb's law in vector form? I'm just writing it as F1, 2, which means its force with respect to 1 and 2 is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R12 square R12 vector. Okay, so R12, the vector is basically unit vector of F12. This is how you write it in vector form. Okay. Okay, next. Mention the expression for electric field at a point due to a point charge in free space. Okay, so students, last class I've not had all of these questions. So these are all previous year 2 markers and 3 markers. Okay, in last class I've just taken a lot of, I've taken lots of important topics. So it won't be exactly the same. There are some extra questions here and I've made it all into questions. Yeah. Mention the expression for electric field at a point due to a point charge. So electric field is 1 by 4 pi epsilon naught. The charge Q divided by the square of the distance. Okay. Here you have only one point charge. So you have a point charge. This point charge Q and it is at a distance R. So the electric field at this point is what we are finding. So the electric field at that point will be equal to 1 by 4 pi epsilon naught Q by R. Next, draw the electric field lines for. Now, if the question is Q greater than 0, you should understand that Q greater than 0 means you are asked for Q positive. Okay? So Q positive. So you have to draw positive charge and then the field lines going out. Field lines always move out of a charge. Okay. Next is Q less than 0. Q less than 0 means what? It is negative. So all the field lines will move into the charge. Okay. Now, if you have two positive charges, then what happens? If you have two positive charges, then the field lines are moving out. They're always moving out. Yeah, like this. Moving out. There is no field line in the center, which is here, because field lines are always moving out. Yes. Next is dipole. Dipole is how? For dipole, you should have two opposite charges. So you should have a plus charge and a minus charge. And charges always move out from plus and to minus. So this is how it would be. So in this case, you will have field lines, passing from one charge to another. Okay. Next is properties of field lines. So electric field lines start from positive. They end at negative. Electric field lines never intersect each other. Electric field lines do not form closed loops. Tangent drawn from electric field lines represent the direction of electric field at that point. Okay? Same thing I already discussed. From the positive, it always goes out. Negative, it always goes in. So if there are two field lines, they will never be intersecting like this. They'll always be at their own pace. Okay, next question. Define electric dipole moment and mention the expression for dipole moment. So what is electric dipole moment? The product of magnitude of, so basically it's Q into 2A. Okay. So it is the product of, if this is a dipole, okay, a plus charge and a minus charge at a distance of 2A is an electrical dipole. So the product of one of the charges and the distance between them is called electric dipole moment. Okay, so dipoles are always separated at a distance of 2A. Alright, so P is equal to Q times 2A. Q is the magnitude of A, the charge, and 2A is the separation between the charges. Zara, numericals I will do in my next class. So there's one more class schedule, right? Most expected questions, something like that. So in that class, we will do numericals. For MCQs, I already have done a video. I've mentioned in the last class as well. 100 plus MCQs. The solutions are there in the video itself. Okay, you can refer that. State and explain Gauss theorem in electrostatics. So what does Gauss theorem state? That the total electric flux through any closed surface. Okay, so if you have a closed surface, the total electric field lines passing through it, which is the total electric flux. Electric flux is the total amount of field lines passing through it, is equal to 1 by epsilon naught times the total charge enclosed by the surface. So total electric flux is represented by phi E. Phi represents total flux, E represents electric field. So the total electric flux is always equal to 1 by epsilon naught times the charges on the surface. Okay? I really can't say Ghost 46 You know, it might not, because it's all in hands of examiner. There's no rule as it should repeat or anything like that. It all depends on the examiners. Okay? Yeah, it is the same. Sri, 1 by epsilon naught into Q is the same as Q by epsilon naught. Okay? Next. Hello, Govind, Gaurav. It didn't come. Let's see for exam 3 what happens. When does the torque on an electric dipole kept in uniform electric field is maximum and minimum? The torque on dipole in an external field is maximum when dipole moment and electric field are perpendicular to each other. Okay, Revati. Hi, Revati. Okay. So, when is the torque maximum? When dipole moment and electric field are perpendicular to each other. So, for example, if this is the no, for them to be maximum, if this is the dipole, then this is the electric field. Okay. In this case, when the dipole moment and electric field are perpendicular, in this case it is maximum. And when is it minimum? This is plus Q, minus Q, and then the electric field. In this case, it's minimum when they're parallel or anti-parallel. So electric field can be parallel or anti-parallel, which means if the dipole is in this direction, it can be in this direction or this direction. Okay? Yeah. Dipole always points from the negative charge to positive charge. That's the direction of a dipole. Okay, next one. Very good, Sri. Yes. Okay. Yeah. Yeah. Okay. Next, obtain the expression on a dipole placed in uniform external electric field. This is a 3 marker. So what do we do? You consider an electric dipole. It consists of, I will draw this picture better, plus QE and then minus QE. Okay. So the electric field is like this. Electric field, it's like this. Okay. And then between the two, it is 2A. Okay. So, yeah, this is the figure. So, the force on minus Q, A and B. The force on minus Q at A is what? F is equal to minus QE. And the force on plus Q is F is equal to plus QE. That is what is here, minus QE and plus QE. Now, what is torque? Torque is force into perpendicular distance between the two forces. So, force is QE. The perpendicular distance between the two forces is B into N. See, this is the perpendicular distance, right? B into N. Okay? And that is what? 2A sine theta. Okay? And then you get torque is equal to PE sine theta. Movies ka world. I'm taking a class now. Okay? To upload the PDF, I have to download the PDF, I have to edit it a little, and then I have to upload it on the Telegram channel. How do you think I'll do that when I'm doing a class? Come on, students, See, everything takes effort. Okay? Hi, Suhas. I don't know. Okay. Next question. Obtain the expression for electric field at a point due to infinitely long, straight, uniformly charged wire. Okay. Yeah. So consider an infinitely long, thin, straight wire as shown in the figure. So here, I will take. Now is it clear? Is it clear, Tanu? Okay. So what I have is a uniformly long. So students, what you can do is on your device, can you go to settings, change quality to highest. Okay. And then let's see if it's getting better. Okay, so there's a full infinitely long, wire. It's full of charges. It's like infinitely long. Okay. And the Gaussian surface that I draw around it, it's a cylinder. So what is a Gaussian surface? A surface where the charges are enclosed. So if it's a cylinder, I can draw a long cylinder because the wire is infinitely long. So the best Gaussian surface here is a cylinder. Okay. Now the Gaussian surface has a radius of r and a length of L. Okay. Now electric flux E through the curved surface of the cylinder. So the cylinder has two parts. It has the top surface, bottom surface and the curved surface. So you can see this is the direction of electric field. The pink arrow. Okay. That is the direction of electric field. Okay. So on the top and bottom, the electric field is just parallel to it. So it is just zero. You don't have to consider it. But electric field is actually passing through the curved surface. So here you have to look at the flux only through the curved surface. Okay. The top and bottom, how is it? See, imagine if this is the top surface, electric field is just passing on top of it. It's not passing through it. Even for the bottom surface, electric field is just passing on top of it. I mean below it. Okay. Now through the center, electric field is passing through it, which is through the curved surface. That is why electric flux through the curved surface is taken. Flux is EA, which is electric field into area, which is electric field into 2 pi RL, which is a area of a cylinder. Okay. Now the electric field through the top and the bottom is 0. Now what will the total flux be? The total flux will be the total flux through the Gaussian surface, which is top, bottom and curve. Top and bottom is 0. Okay. So I will just take it as 0 plus E into 2 pi RL. Okay. So 0 plus E into 2 pi RL is E into 2 pi RL itself. Now, the total charge enclosed by a long Gaussian surface Q is equal to lambda L. Okay? Q is equal to lambda L. Now, according to Gauss theorem, what we have, so this Q is equal to lambda L, how it came, it will take some time to explain. I mean, I've already explained this in first chapter alone. I have done a class. Okay. I think it's called electrostatics part 1. There you can refer this. Yeah, I think it's part 1 or part 2. Okay. So Q is equal to, those who don't want to waste time, you can just learn it as Q is equal to lambda L. Now what is Gaussian surface? Gauss law, phi is equal to Q by epsilon naught. What is Q? Lambda L divided by epsilon naught. Yeah? Q is lambda L. Now, what I will do, I already know that phi is equal to 2 pi RL times E. Now I also know that it is equal to lambda L by epsilon naught. So now when I equate it, what is E? E is equal to lambda L divided by 2 pi RL epsilon naught. L and L cancels. What remains? Lambda divided by 2 pi epsilon naught R. That is the answer. Okay? Tanu, don't worry. I am writing all the important steps. Okay? Next question. Derive an expression for electric field at any point near the surface of a uniformly charged infinite plane sheet using Gauss law. Okay? I have uploaded the PDF of yesterday's class. Please check Vedantu Karnataka Telegram channel. All the other students have got the PDF. Okay? Please check the Telegram channel. It's there. Yeah? Okay? Yes. Derive an expression for electric field at any point near the surface of a uniformly charged infinite plane sheet using Gauss law. Now, this is the surface. Okay? So So here what we are considering is, we are considering a sheet. Okay? So we are considering a thin infinite plane sheet. And this plane sheet has a lot of charges. Okay? Now what I'm going to take is, I'm going to take a Gaussian cylindrical surface passing through it. Okay? So there's a sheet and there's a Gaussian cylindrical surface passing through it. Okay? Now, due to symmetrical charge distribution, electric field at any point near the sheet is normal to the plane. Isn't it? So if this is the sheet, electric field at any point is in that one direction. So now here, this cylinder has two surfaces, right? One surface, second surface, and then the curved surface. Now, are there any field lines passing through the curved surface here? Here there are nothing, right? On the curved surface there is nothing here. Here the electric field lines are passing through the sides of the cylinder. So if this is a cylinder, it's passing through the sides of the cylinder. Through the curved surface, there is nothing passing. So the flux on the curved surface, I can take it as 0. Okay. So the electric flux through the curved surface phi 1 is 0. Okay. Electric surface through the curved surface phi 1 is 0. Okay. No field lines cross this region. The circular regions are equidistant, hence electric field is the same at both the circular paths. Perfect. Now what I'm going to do, I'm going to take this side and this side. Both these sides will have the same electric flux. Okay. So this electric flux will be EA. Here also it will be EA. Okay. Now what will the total electric flux be? EA plus the curved part plus EA. Curved part is 0. So the total electric flux is phi is equal to phi 1 plus phi 2 plus phi 3, which is 0 plus EA which is 2EA. Okay. Now what to do? Gauss law states that phi is equal to Q by epsilon naught. Okay. Now Q is what? Sigma into A. So we already know that phi is 2EA. So 2EA is equal to sigma A by epsilon naught. E is equal to sigma by 2 epsilon naught. This is the answer. Okay. So this is the expression for electric field on a infinite uniform sheet, charged plane sheet. Okay, on a plane sheet, the Gaussian surface is a cylinder. You find out the flux through the two flat surfaces on the cylinder. That's all. Okay. Yes. Yes, I had my breakfast, Renuka. Did you have your breakfast? Okay, that was to Suhas, not to me. Okay. Okay. Next, we will discuss the chapter electric potential and capacitance. Okay. Students, just a minute. I just need some water. Yes, I have it. Um, Yeah, Dia, please also share the video links to your friends. Okay, so if they have doubts, because on the PDF, some things won't be clear. I've explained those in class. Okay, so all of you, please, when you share the PDF, please send the video also to your friends. Okay, so they get to refer that as well. All right. Okay, so electrostatic potential and capacitance. What are equipotential surfaces? Okay, first question. What are equipotential surfaces? Write the properties of equipotential surfaces. An equipotential surface is a surface where the potential is the same or it is the constant throughout. Okay. Renuka, you can just go to Vedantu Karnataka Telegram channel and notes are there. Okay, you don't have to take anybody's number for that. Alright. Yeah. See, in between you're all. The properties of equipotential surface are, this we've already discussed in the last class. What is it? The work done in moving a test charge from one point to another on an equipotential surface is zero. That is, since if there's an equipotential surface and the charges are moving together, from one point to another. Okay? Okay, and the charges are moving from one point to another. Since the potential is the same throughout on the surface, wherever you go, since the potential is the same, there is no work done in moving any charge anywhere. It's the same everywhere. Okay? For any charge configuration, equipotential surface through a point is normal to electric field. Okay? From the surface, it's all going normal. And the surfaces will never interact. Okay, next question. Mention the factors on which capacitance of a parallel plate capacitor depends. So we've already discussed this. Capacitance is what? Epsilon naught A by D. Okay? Yeah. So it depends on the area between the plates, the area of the plates, the separation between the plates, and dielectric constant of the medium between the plates. I'm not very sure, Sriram. I have to check on that. Okay. I don't want to give you false information. So I'm not very sure on that. Okay. Next question. Derive the relation between electric field and potential for a point charge. Okay. So a unit positive charge is moving along a perpendicular, from surface A to surface B. Okay, so this is one surface. Okay, the next surface I'll draw with a different color. This is another surface. Okay, the upper surface is surface B. The lower surface is surface A. Okay. Now the potential on surface A is V. The potential on surface B is V plus delta V. Okay. Yeah. The work done in this process is, the work done is what? E delta L. And what is the potential difference? The potential difference is there are two surfaces, okay? The lower surface is A, the upper surface is B. So the potential difference between the two surfaces is VA minus VB. Okay? So that is also equal to work done. So this is equal to VA minus VB. VA is how much? V minus VB is V plus delta V. What is this? V minus V cancel. It is just minus delta V, which is minus delta V. So you will get electric field is equal to minus delta V by delta L. Okay. Now if you don't look at the sign, if you take the mode, it becomes plus delta V by delta L. Okay. Yes, let's move on. Next question is also a 3-mark question. Obtain the expression for potential energy of a system of two charges in the absence of an electric field. Okay. So let's consider 2-point charges Q1, Q2. Okay. And their position vectors are R1 and R2. 2-point charges Q1 and Q2. Position vectors R1 and R2. Okay. Obtain an expression for potential energy of a system of two charges. You have two charges. There is no electric field. Okay. So work bringing. So initially there is nothing. Okay. Empty space. And you bring a charge Q1 from infinity to a point R1. Okay. So you bring Q1 from infinity to a point. But there is nothing else. There is no electric field. There's no other charge. There's nothing else. So obviously it can smoothly come. The work done on it will be 0. Because there is no effect of anything. It's just a single charge coming. Okay. Now this charge will have a potential around it. And that potential is V is equal to 1 by 4 pi epsilon naught Q2 by R. Okay. So when you bring charge Q2, so there is Q1 here. When you bring charge Q2 close to Q1, this Q2 will experience a force. This Q2 will experience some potential. This Q2 will experience some work done. Why? Because it is in the presence of another charge Q1. Okay? Yes? Okay? So, yeah. The work done in bringing Q2 from infinity to R2, it will be what? W2 will be the potential it experiences into Q2. Okay? So this is a correction here. Yeah. This is Q1. Yeah. Q1. Okay. V is the potential because of Q1. Okay. So the work done to bring Q2 here, the work done is what? Potential into Q2. So this is going to be equal to 1 by 4 pi epsilon naught Q1 by R is the potential into Q2. Okay. Now what is the total work done? The total work done will be W1 plus W2, which is the work done in bringing the first charge Q1 plus the work done in bringing the second charge Q2. What is the work done in bringing the first charge Q1? 0. Because it can simply come. There's nobody else. Yeah. Now, the second charge Q2 comes with some work done. which is 1 by 4 pi epsilon naught Q1 Q2 by R12. So the total work done is 1 by 4 pi epsilon naught Q1 Q2 by R12. Okay. So the electric potential energy of 2-point charges is what? The total work done in bringing each charge from an infinite distance to the location. So from infinite distance, you bring the first charge, no work done. You bring the second charge, work is done because it experiences a force because of the first charge that you brought. So work done is the same as potential energy. So you will get U is equal to 1 by 4 pi epsilon naught Q1 Q2 by R12. Okay? Yes. Are you all understanding? This is not that difficult. Yeah? It is just the expression for potential energy of a system of two charges coming together when there is no electric field. Okay? Okay. Next question. Derive the expression for equivalent capacitance of two capacitors connected in series. So all this we haven't discussed in yesterday's class. These are all 3 markers. Okay. So the expression for equivalent capacitance of two capacitors connected in series. So let's say you have a capacitor C1, capacitor C2. Okay. Together, if you find out the capacitance of C1 and C2 and you add them together, you will get the capacitance of CS, which is C1 plus C2. Okay. Okay. Yeah. So now let's find out that. So first thing what we will do, since it's in series, whenever you find something in series, even if it is to find total EMF in series or capacitance, whatever it is in series, voltage is always divided. Okay. So in series, if you have 5 capacitors or 5 components, voltage is divided between each of them. Okay. So the total voltage will be V, which is equal to V1 plus V2 plus V3. How many ever are there? It will be just the same. Okay. Now, we already know for capacitance, what is the formula? If you don't know, you should learn now. Okay. So, Q is equal to CV. If you have a charge, that charge is equal to capacitance times potential. Q is equal to CV. So, V is equal to Q by C. Okay. So, now for we already know V is V1 plus V2. So, let's substitute. What is V1? Q by C1 plus what is V2? Q by C2. Now, this is equal to Q, I'll take it outside. 1 by C1 plus 1 by C2. Okay. Now, we already know what is the potential. V is equal to Q times 1 by C1 plus 1 by C2. Okay. Now, V I will substitute as Q by C. I already have that. So, I will write Q by C is equal to Q into 1 by C1 plus 1 by C2. Yes. So, Q by C is equal to Q into 1 by C1 plus 1 by C2. I got this much. Now, what I'm going to do is, I am going to write this as CS. Okay. So, Q and Q will cancel. So, what do I get? 1 by CS is equal to 1 by C1 plus 1 by C2. Okay. So, the total capacitance of two individual capacitors that are, connected in series, the total capacitance is 1 by C1 plus 1 by C2. Okay. So, for this CS is equal to 1 by C1 plus 1 by C2. Okay. Yes. Okay. Next question. Derive the expression for equivalent capacitance of two capacitors connected in parallel. Okay. So you have one capacitor and then the second capacitor. Both of these capacitors are connected in parallel. Okay. So that combined capacitance CP. So here this is CP. The combined capacitance CP is what you have to find. So this can be written equivalently as CP alone. Okay. So that is what you have to find out. Now, consider two capacitors C1 and C2. They're connected in parallel with a potential difference V, blah, blah, blah. Okay. So here what we're going to take is, we're going to take the charges. So total charge is equal to the charge on capacitor 1 plus the charge on capacitor 2. Now what is Q? We know Q is CV. So CV will be C1V plus C2V. Why don't I write it as V1 and V2? Why do I write it as only V? Because it's in parallel. In a parallel circuit, voltage is same everywhere. Okay. Now this C, I can write it as CP because it's the total capacitance, right? Total capacitance is equal to the capacitance in parallel. I will write it as CP. Okay. Now all the V is the same. So I can cancel all the V. What remains? CP is equal to C1 plus C2. Okay. So this CP is equal to C1 plus C2. That's all. Very easy. Yes. So all the steps are mentioned here. You can go through these. Okay. Let's move on to the next chapter, which is current electricity. Okay. So for current electricity, what is the first question? Define drift velocity of conduction electrons. Mention the expression for drift velocity. Okay. You have to define drift velocity and mention the expression for drift velocity. So the average velocity with which conduction electrons in a conductor gets drifted against applied electric field is called drift velocity. What is the meaning of that? You have a conductor. Okay, let's say this is a conducting wire. So many electrons inside it. So when you apply an electric field, these electrons start to move. And the velocity by which they start to move is called drift velocity. Okay. And the expression is Vd is equal to minus EE by M tau. Okay. Okay. Yes, no. Okay. Next question. State and explain Ohm's law. Okay. So the current through a conductor is directly proportional to the potential difference across its ends is Ohm's law, which means if you have a wire and you have some current passing through it, the current is directly proportional to the voltage. Okay. Or voltage is directly proportional to current, provided the temperature is constant. Okay. So temperature shouldn't keep on changing. The temperature should be a constant. Now, if I remove the proportionality, this becomes V is proportional to I, V is equal to I into R. So I remove the proportionality and I add an equal to sign along with R, which is a constant. Okay? Yeah. So let's move on. Now you have to mention the limitations of Ohm's law. Limitations of Ohm's law are what? Ohm's law is not applicable at very low and very high temperature. Ohm's law is not applicable for non-ohmic devices such as semiconductors, transistors, discharge tubes and superconductors. Ohm's law is only applicable when temperature and other physical conditions are kept constant. I already discussed this, right? It should be at constant temperature, otherwise it does not work. Okay? Yes. Explain the dependence of resistance on the dimensions of a conductor. What is the formula for resistance? R is equal to rho L by A. So obviously R is directly proportional to L. R is inversely proportional to area. Okay. So the resistance of a conductor is directly proportional to the length, inversely proportional to area. So from this you get the dependence of resistance to the dimensions of a conductor. Okay. Next is state Kirchhoff's laws of an electrical network. So what is the Kirchhoff's first law? The sum of currents entering the junction is equal to the sum of currents leaving the junction. So if you have, let's say, 4 currents, okay, I1 and I2 enter, I3 and I4 leave. So then I1 plus I2 should be equal to I3 plus I4. That's how it would work. Okay? Yeah. Next, Kirchhoff's second law. In a closed loop, the algebraic sum of the changes in potential consisting cells and resistance is 0. So, the EMF minus current and resistance, which is potential, in a closed loop, in total, it will be equal to 0. Okay? Yes. Next one is deduce the expression for drift velocity of conduction electrons. Hi Hamsu, hi Suchitra, hi Bharati. Okay, so in a conductor, the free electrons are in random motion. Yeah, so initially they don't move, it is 0. But when an external field comes in, from Newton's law, F is equal to ma, so A is equal to F by m. Now what is F? The number of charges moving in an electric field. So it's going to be minus E is the number of charges into electric field, the whole divided by m. Okay, so E is the charge of the electron and m is the mass of the electron. Now, if you want to find out, the velocity of some random electron, what you do is you take V is equal to U plus AT. Okay, but you put I to it because it's just a random electron. Okay, UI. So VI would be equal to UI plus ATI. Okay, now U is what? Okay, I can write this as V1 is equal to UI plus, instead of A, I will write it as minus E by M Ti. Okay? That's a general form. Now, to find out drift velocity from this, what will I write? V1 is what? Drift velocity. And when it's drift velocity, U1 is 0. So, 0 minus E by M. And time will be relaxation time, which is tau. So, Vd will be equal to minus E by M tau. Okay? Yes? Yeah, okay. Yeah, last class, it was only a 3-hour class. Okay, that 9 hours you saw because the live didn't end. Okay, so YouTube just has some error. Sometimes the live doesn't end by itself. So after 9 hours, it got ended by itself. That's all. The class was only for 3 hours. Okay, and the full PDF I've uploaded. See, students, read through the PDF, check on whatever is there, and then you come and tell me on YouTube. Okay? Yeah. Yeah, yes, exactly. Movies covered. Check properly. Okay? Deduce an expression. See, we're taking so much effort in doing all this, and you don't even take the effort to check if the whole thing is there, and you come and complain. Okay? Yeah. Deduce an expression for effective resistance of two resistors in series combination. Okay, the first resistor is R1, the second resistor is R2, and they are both connected in series. In total, the effective resistance is taken as RS. So RS is because of R1 and R2 in series. Okay. Now what we will do, we will just take the voltage. So the total voltage is V1 plus V2. So what is V1? Voltage is current into resistance. So V1 is current into R1 plus current into R2. What is current? I mean, why is it I, not I1 and I2? Because this is a series circuit. In a series circuit, current is the same everywhere. So you don't have to individually take it as I1 and I2. You can just normally take it as I. Okay? Yeah. So V is equal to, I will take I outside. What remains? R1 plus R2. Now, what is this V? I into R series is V. This is equal to I into R1 plus R2. So, I and I cancels. R series is equal to R1 plus R2. Okay? Yes. Next question. Derive the expression for equivalent EMF and equivalent internal resistance of series combination of two cells. Okay. So we looked at series and parallel capacitances. And then you looked at series and parallel resistances. Now we're going to look at series and parallel internal resistance and combination of cells. Okay. Yeah. So you have two two cells. Okay. Epsilon 1, sorry, not epsilon 1, E1 and E2. This is the EMF of the two cells. R1 and R2 is the internal resistance of the two cells. Okay. So now this is going to be the combined EMF is E equivalent and R equivalent. Okay. So what is E equivalent? E equivalent is E1 and E2 together in series. Whatever value you get, that is going to be E equivalent. Okay. Yes. Ma'am, ragging. Who am I ragging? Or did you mean lagging? Just brawl. Brawl. I'm sorry if I'm pronouncing your name wrong. Okay. So the terminal potential difference across each cell is, the general formula is V is equal to E minus IR. Okay. So V1 is what? E1 minus IR1. V2 is equal to E2 minus IR2. Okay. So then V will be what? V1 plus V2. We already know. So this is going to be equal to E1 minus IR1 plus E2 minus IR2. Okay. Now this is going to be equal to what? E1 plus E2 minus, I take I outside, R1 plus R2. Okay. which is V. Alright, E1 plus E2 minus I R1 plus R2. Now what I'll do? Yeah. This E1 and E2 together I will write it as E equivalent, my E equivalent minus I times R equivalent is equal to V. So from this clearly what is E equivalent? E1 plus E2, and what is R equivalent? R1 plus R2. Okay? Okay. Next chapter. Moving charges and magnetism. So right now we're discussing all the 3 and 2 markers. Okay, no 5 markers I've discussed. I will discuss 5 markers. So this is all 3 markers and 2 markers. Okay. Yeah. Moving charges and magnetism. Write the expression for magnitude of force on a charge moving in a uniform magnetic field. Okay. So magnetic force is what? QVB sine theta. Magnetic force is QVB sine theta. Now, as I said in the last class, you have to explain each term. Okay, even if it's for a 2 marker, F is equal to QVB sine theta will fetch you only 1 mark. You have to say B is magnetic field. Q is magnitude of charge, V is velocity of charge, theta is the angle between V and B. Okay. Now, when does the force experienced by a charged particle moving in a magnetic field is minimum and maximum? So, force is maximum when charge is moving perpendicular to field. Force is minimum when charge is moving parallel to the field. Every time, right? See, if there is a field and the force and then the charge is moving along the field, which is parallel, then it does not have any force. It's minimum. But if it's moving against the field, which is perpendicular, that's when the field will be maximum. Okay. Let's move on to the next question. State and explain Ampere's circuital law. The line integral of magnetic field around a closed path or boundary, integral B dot dl is equal to nu 0 times the total current I through the surface that enclosed by the path. Thank you, Just Broad. Thank you for all your support, It all means a lot to me. Okay, so integral B dot dl is equal to mu 0 I. Even if it is 180 degrees, it's the same. Parallel or anti-parallel, right? It's not going to make a difference. Okay. Yeah. Okay. So state and explain Ampere's circuital law. So yeah, what is Ampere's circuital law? In a closed boundary, the magnetic field passing through that particular area is always equal to nu 0 I. Next question, what is a solenoid? Write the expression for magnetic field inside the current carrying solenoid. So what is a solenoid? So you have a wire, a straight current carrying wire, and a straight current carrying wire always has a magnetic field around it. So this current carrying wire is made into a loop. Okay, so it's made into a loop and then you insert an iron core in it. Now this becomes a solenoid. Now there is current passing through this coil. Okay, yeah, this current passing through this coil. Now this becomes a solenoid. So what is solenoid? A solenoid is just a long wire. It is made in the form of a helix. Okay, it is just wound in the form of a helix. Now magnetic field inside the solenoid is B is equal to nu 0 Ni, where N is the number of turns, I is the current, and nu 0 is the permeability of free space. Okay? Yeah. You don't need to know about a toroid. Okay. Next question is Biot-Savart's law. What is Biot-Savart's law? the magnitude of magnetic field due to at a point due to a current element is. So what you have is a wire. Okay. So on the wire, you take a small part of the wire, and you just name it DL. Okay. And you find a point P outside the wire. You find out the magnetic field due to this current carrying wire at point P. Okay. The wire has current passing through it. Alright. So you have a current carrying wire. The magnetic field due to a current carrying wire at a point P at a distance R is what is Biot-Savart's law. Okay. Yeah. So first point, let me write that here. dB is proportional to the strength of the current. So whatever magnetic field P experiences, it is proportional to the strength of the current. It is proportional to DL. DL is the length element. It is proportional to the sine of the angle between it. Sine theta as well. It's proportional to sine theta. It is inversely proportional to the square of the distance between it, which is r square. So combining all of this together, you get the Ohm's law, Biot-Savart's law. dB is proportional to ideal sine theta by r square. Now to remove the proportionality symbol, you insert a constant which is nu 0 by 4 pi, and then you get dB is equal to nu 0 by 4 pi ideal sine theta by r square. Okay? Okay. Next question. Derive an expression for magnetic field due to a straight conductor of infinite length carrying current using Ampere circuital law. So you have a wire, okay? You have a straight conductor of infinite length, and this is carrying current, okay? The current is X, the conductor is XY, it's carrying a current I. Now let's take P a point that is at a distance. P is a point which is at a distance R, okay, around the wire. It's around the wire, okay. Now, since every point on this loop is at the same distance with respect to the wire, okay, so it's all at a distance R. All the points are at a distance R with respect to the wire, okay, and magnetic field B is also the same at all points. B is same at all points. Now we'll just apply Ampere circuital law. What is Ampere circuital law? Integral B dot dl is equal to mu 0 I. Okay. Now this is what B I will take outside. Integral of dl is equal to mu 0 I. Now what is dl? It's a loop. So if you take a small part of a loop and you integrate it, you will get the circumference, which is 2 pi r is equal to mu 0 I. So from this, B is equal to nu 0 I divided by 2 pi r. That's all. Right? You have a straight current carrying wire. You take a point P such that point P is at a distance r. Wherever you touch it around the wire, and then you apply Ampere circuital law. Okay? Yeah. You have to attend the whole class. If you attend the whole class, I can give you the PDF. Okay? Yeah. Which circuit diagram explains how can a galvanometer with circuit diagram, okay? This is with. Yeah. With circuit diagram explain how a galvanometer can be converted into an ammeter. So how can you convert it? You take a galvanometer, okay, and you connect it to a low resistance in series. Okay? A low resistance in series. Sorry, in parallel. You connect a low resistance in parallel, you convert it into, an ammeter. I will draw it properly here. Okay, so this is your galvanometer. To that you connect a low, what is this? Students, are you hearing a disturbance? Because there is some disturbance here. Hey, something is wrong. Okay, yeah. Okay, so let's say a current I comes in. Okay, let's say a current I comes in. This current, half of it goes to Ig, the rest goes here as I minus Ig. Okay, Ig goes to the top arm, I minus Ig goes to the bottom arm. So this is S, this is G. So what is the total current? The total voltage. So voltage is what? IR. Okay. So the total voltage reaching the resistance is what? S times I minus Ig is the total voltage reaching the resistance. And this should be equal to Ig into G. Why? Because V1 is equal to V2. Since this is a parallel circuit, in a parallel circuit, voltage is same everywhere. Now, if you rearrange that, you will get S is equal to IgG divided by I minus Ig. Okay, did you understand how you got this first equation? It's just that voltage in a parallel circuit is equal everywhere. So the voltage on the galvanometer should be equal to the voltage on the low resistance. What is the voltage on the galvanometer? Current into resistance, which is IgG. That should be equal to I minus Ig into S. Okay, super. Let's move on to the next question. State and explain with a suitable diagram how you can convert a galvanometer into a voltmeter. Okay. So to convert a galvanometer to a voltmeter, you connect a high resistance in series. Okay. High resistance in series. So let's say a current of Ig comes, okay, and the current of Ig leaves. Because in a series circuit, current is the same everywhere. Okay. Now, the total voltage will be the current into resistance. So, what are the resistances? G plus R. Yeah. In a series circuit, if you have 2, 3 resistors, the total resistance is just adding them up. So, from this, I will get V by Ig is equal to G plus R, and then R is equal to V by Ig minus G. Okay. This is how you convert a galvanometer into a voltmeter. Okay. Next is magnetism and matter. Write the properties of magnetic field lines. So north, south. Magnetic field lines start from the north pole, they go into the south pole. They go into the south pole. Yeah, the first property, it starts from north pole, it ends at south pole. They form continuous loops. They do not intersect. The tangent to the field line at a given point represents the direction of magnetic field lines at that point. If you have larger field lines, it means the magnet is stronger there. So if you can see a magnet, near the magnetic field lines would be very close. As you go away, the magnetic field lines will be more far apart. Okay, so that actually determines the strength of the magnet. Magnet has more magnetism very close to it, right? That's why magnetic field lines are more close near the magnet. Okay, next question. State and explain Gauss law in magnetism. Mention its significance. So Gauss law states that the magnetic flux through any closed surface is 0. So if you have any closed surface, the number of field lines entering and the number of field lines leaving, it is equal. How many ever field lines enter the magnet, that many number of field lines leave the magnet as well. So that is the Gauss law. What is the significance? The significance is that from Gauss law, it was proven that magnetic monopoles do not exist in nature. Okay, what does that mean? That means that if you have a magnet, North Pole, South Pole, okay, you cut it, you get another magnet which also has a North Pole. You get two magnets which also has two poles. If you cut this again, you get another two magnets which has North Pole and South Pole. So how many ever small pieces you make it, it will always have a North Pole and South Pole. It cannot exist as a single pole or a monopole. There will never be a magnet which has only North or only South. Okay? Next. This is not required. This is not required. This is not required. Yeah, from here. Write any three properties of diamagnetic materials. What are the three properties of diamagnetic materials? So you can just write down any three out of these. Okay, so they are weakly repelled by strong magnetic field. The magnetic susceptibility is small and negative. The relative permeability is less than 1. The permeability is less than absolute permeability. Their susceptibility is independent of temperature. Okay, next, properties of paramagnetic material. So as I said, I've already said in my previous classes, students, when you learn this, I want you to write down on a piece of paper, on a book, dia, para, ferra together in a page as 3 columns. Okay, and then you have to write down the points for each and then compare and learn. For example, for dia, the susceptibility is small and negative. But for para, susceptibility is small and positive. And for ferro, susceptibility is large and positive. So if you look at all these three together, you will see that, you can compare and learn. Okay? So otherwise you will be confused. So write it as a table, compare it and learn. Okay. Now, the relative permeability is also slightly more than 1. Permeability is more than absolute permeability. The susceptibility varies inversely with temperature. Next, magnetic properties of ferromagnetic materials. They are strongly attracted by magnetic field, weakly magnetized in external magnetic field. It's large and positive. Relative permeability is much more than 1. The permeability is many more times than absolute permeability. Susceptibility varies inversely with temperature. You can learn like 4 or 5 points if you can. Learn at least 3 points. Okay? Don't learn less than 3. You have to learn at least 3 points. Okay. Next is electromagnetic induction. So this is an experiment to demonstrate, the electromagnetic induction. So you have a coil and then you have a magnet. So this magnet goes into the coil. The moment the magnet goes into the coil, the galvanometer shows deflection. So if the north pole goes into the coil, it shows deflection on one side. Now if the south pole goes into the coil, it shows deflection on the other side. Okay. So now if the magnet is stationary and the coil moves, even then it shows a deflection on two sides. Okay? Yeah. Next is state and explain Lenz's law of electromagnetic induction. So what does Lenz's law state? That the polarity of induced EMF is such that it tends to produce a current which opposes the change in magnetic field that produces it. So this is also a 3-mark question. Okay? So when the north pole of a bar magnet is pushed towards the closed coil, the current is induced in the coil in a direction such that it opposes the electric flux. This is possible only if the current in the coil is in the opposite direction. Now, if the north pole comes, it's again the opposite. Now, next one. Derive an expression for motional EMF induced in a conductor moving in a uniform magnetic field. So, if you have a coil, okay, and then you have a conductor that can move. This is a conductor that can move. Yeah. Where did all my students go? Yeah, they're all here. Okay. And then there's a conductor that can move. Are you all there in class? Please put some fire emojis in the chat if you're all there in class. Quickly, quickly. If you all sleep off. After this, we will discuss all 5 markers. Okay. Yes, where are the fire emojis? Okay, so let's consider a straight conductor. It can move, okay? It can move with the velocity of v. Okay, Afira is there. It can move with the velocity of v. Ghost 46 is there. Then, who else? Now, the magnetic flux of the loop, which is P, Q, R, S. The magnetic flux of the loop PQRS is what? Phi is going to be equal to B into A. Okay? Cos is anyway 0, so no need to take cos. What is area going to be equal to? L into X, side into side. L into X. Now we already know what the EMF is what? Minus d phi by dt. What is phi? Minus d BLX by dt. Now, what is, I will take all the constants outside. So, minus BL. dx by dt is what? V. So, minus BL V. Okay. So, this minus d, this will be plus because minus dx by dt is V. Okay. Yes. Let's move on to the next question. Derive the expression for energy or magnetic potential energy stored in the coil or solenoid carrying current. Let dW be the work done in developing the current I in an inductor in time dt. Let E be the EMF induced in a conductor. The rate of work done is given by. Yeah. So power is what? Work done by time. Now work done is what? Charge into potential by time. Now if you take charge into I, you will get, it is nothing else but EI. Okay. So now this much is general formulas. Now the rate of work done, how will I get? If you want to find out the rate of whatever value you want to, you always take dW by dt. If you want to find out rate of potential, dV by dt, rate of current, di, rate of work done, dW. So dW by dt is equal to E into I is the current in the conductor. Okay. Now this is the same as, what is E? E can be written as L into di by dt. So Li di by dt. Instead of E I write L di by dt cancels. So dW is Li into di. Okay. Now what I am doing is simple integration. Okay. So W is what? The integral of dW is W. Integral of Li di will be what? This is a general formula for integration. Integral of x raised to n dx is x raised to n plus 1 divided by n plus 1. So it's going to be equal to I plus 1 divided by 1 plus 1 I square by 2. So that's how you get 1 by 2 Li square. Now this is work done. Work done is equal to potential energy. So potential energy will also be equal to half Li square. Okay, I'll just show this to those of you who are confused. So I'm just going to integrate I di from 0 to I. So this is going to be equal to 0 to I into 1 plus 1 divided by 1 plus 1, which is I square by 2, 0 to I. Now when I apply the limit, this becomes I square by 2 minus 0 square by 2, which is I square by 2. That's how I get it. Okay. Okay. Next question. What are eddy currents? How to minimize the eddy current? Mention the use of it. So eddy currents are currents in the thick conductors. Okay. Due to, for example, in a transformer. So in a transformer, you have a thick iron core. So from the primary coil to the secondary coil, when the magnetic flux is changing, okay, it induces a current. That is called eddy current. Now, eddy current can be minimized by laminating the iron core. Okay, whatever case, not just in transformers, in any case, it can be reduced by laminating the metal core. Okay, and eddy currents are used in so many things. It's used in the transformer also. Okay. Madhu, do you want me to do math questions? Is that what you meant? Okay. So alternating current. Show that voltage leads current by pi by 2 when AC voltage applied to when AC voltage applied in pure inductance. Okay. So you have an AC voltage that is applied to an inductance. I have to show that the voltage leads current by pi by 2. So first thing, the AC voltage, what is the formula for AC voltage? V is equal to Vm sin omega t. Okay. Now, if di by dt is the rate of change of current, then the EMF induced is going to be equal to minus L di by dt. Okay. EMF is minus L di by dt. Now, we already know that V plus epsilon is equal to 0. Yeah. So, Vm sin omega t minus L di by dt should be equal to 0. Yes, that is this formula should be equal to 0. Yes, is it clear till here? Okay. Now I take, I equate it. So Vm sin omega t is equal to L di by dt. I take L also to this side. So I take L also to this side. So this becomes V by L. So integral. Now I'm going to take the integral. What is the integral of di by dt? Integral of di by dt is I is equal to Vm by L integral of sin omega t dt. Perfect? Yes. Now, this is going to be equal to Vm by L. What is the integral of sin omega t? Minus cos omega t divided by omega. Integration. Okay? So, I is now equal to Vm by L. I will write it as Im. minus cos omega t by omega. I can write it as sine. I can write it as sine omega t minus pi by 2. Okay? And that is my formula here. Okay? Yes. So, from equations 1 and 3, it follows that current through an ideal conductor lags behind the voltage by pi by 2 because it's minus pi by 2. It's minus pi by 2, so it lags behind by pi by 2. Okay? RXBTCC. I will be doing lectures on CBSE as well, okay? I'm just going to do lectures on NCRT once exam 3 is done. I will do chapter wise videos on NCRT chapters. Okay, don't worry. Yes? Is that okay, RXBTCC? Alright. Next question is a similar question, but here. So you're going to write the board exam next year, right? Next question. Show that current leads voltage by pi by 2 when AC voltage applied to pure capacitor. So students, all of you, please do subscribe to the channel, like and share these videos, okay? Because if these videos don't get to people, then we won't be able to continue with the channel, okay? So for the channel to grow, we need your support. We will give you all type of content you need. Whatever you need, we'll give you all that. Okay? You want class-wise chapter, you want chapter-wise class, you want whatever you want, you can just let us know in the comment. We will do videos on all that. But the only thing that we need from you is subscriptions, likes and shares. Okay? Because without that, we'll have to shut down the channel. We will not be able to, take the channel forward. So if you want us to take the channel forward, please do support us. Send this to all your friends. Send all these videos to your friends preparing for exam 3. Tell them to watch the videos. Tell them to subscribe. Okay? And all of you, please like the video as well. Okay. Yeah. So here again, same steps. First steps are the same. V is equal to Vm sine omega t. Same step. Now what we're going to take is, see, here an AC source is connected to a capacitor. So whenever the capacitor gets charged and discharged, it's from the AC source. From the AC source, the capacitor gets charged and discharged. Okay. Now imagine Q is the charge on the capacitor. Then the voltage across the capacitor will be given as Q by C. Okay. So if Q is the charge on the capacitor, then the voltage is given as Q by C. Okay. So Q by C will be equal to, both of these will be equal. So Q by C will be equal to Vm sine omega t. Okay. This M comes here. Yeah. Vm sine omega t. Okay, I'm just writing all this because it might not be very clear here. I don't know what happened, but yeah. So from this, then I cross multiply. So Q is equal to CVm sine omega t. And we already know what is current. Current is charged by time. So I is equal to dq by dt. So this is equal to d by dt of CVm sine omega t. Yes. CVm sine omega t. CVm sine omega t. Yeah. This is equal to CVm is a constant. Sine omega t is cos omega t into omega t plus pi by 2. Okay. So I would be equal to Im. C into Vm, I'll write it as Im. And then omega cos omega t into pi by 2. This will be sin omega t plus pi by 2. So this step is not required here. Okay. So Im is what? CVM. Cos sin omega t is minus cos omega t. That can be written as sin omega t plus pi by 2. It's a small correction here. Okay. Now, Im is omega c Vm. Okay. Students, don't forget to put that omega, okay? Sine of omega t, when you differentiate it, it becomes omega into the differential. So that omega will also come into Im term. Okay, next, derive the expression for resonant frequency of a series LCR circuit. So what is resonance? Resonance is where the inductive reactance, okay, inductive reactance becomes equal to capacitive reactance, so that the current through the circuit will be maximum. Okay. Yeah. Now, next question is expression for resonant frequency. Hi, Rohan Thakur. Hi, Mahi. Okay, so the frequency of applied AC at which current in the LCR circuit becomes maximum is called resonant frequency. Okay, so XL is equal to XC. What is XL? Omega naught L minus, is equal to 1 by omega naught C. So omega naught cross multiplication, omega naught square is equal to 1 by LC. So omega is equal to 1 by square root of LC, and then V naught is 1 by 2 pi LC. This is the expression for resonant frequency. Next question. Write the expression for power consumed in an AC circuit. So power consumed is P average is equal to VRMS into IRMS times cos phi. Okay, so VRMS and IRMS, they are the values of voltage and current, and phi is the phase difference between voltage and current. Okay. Yes. Next is, what is a transformer? Working principle, mutual induction. Mention any two causes of power loss: eddy current, magnetic flux leakage, heating because of resistance in wires. They're all different kinds of power loss in transformers. Okay. Now, what is displacement current? Mention the expression for displacement current. So, displacement current is the current that is not because of actual charge is moving. It is because of the changing electric field or flux. Okay. So, whenever there is a electric current, and there is a changing magnetic field, change in electric field, current produced like that is called displacement current. And the formula is ID is equal to epsilon naught d phi E by dt. Next. Next is the expression for speed and electromagnetic wave in vacuum in terms of permeability and permittivity. Very easy. C is equal to 1 by root of epsilon naught mu naught. Okay? Okay? Yeah. Next is ray optics. the very interesting ray optics. Some of you don't like ray optics, no? Do you all like ray optics? Can you let me know in the comments? Do you like ray optics or not? Yes or no? Yes or no? No response? You all hungry? Okay. First one, state laws of reflection. What are the laws of reflection? If you have a surface, you have a normal, you have an incident ray, you have a reflected ray. So the incident ray, reflected ray, normal all lie on the same plane, and the angle of incidence and angle of reflection are always equal. Okay, anime fan says it's the easiest chapter. Okay, very good. Next, state and explain Snell's law of reflection. What is Snell's law? The ratio of sine of the angle of incidence and sine of angle of refraction is a constant, which means sine I, n1 sine I is equal to n2 sine I. Right? Praju, hello. Okay. Next is, what is total internal reflection of light? And what are the conditions for total internal reflection? So what is total internal reflection? Imagine you have a surface, you have an incident ray coming in, and the reflected ray does not pass. Okay, this is medium 1, this is medium 2. This does not go like this. It just stays within. So then it is said to undergo total internal reflection. Okay, so when a ray of light passes, the condition is that the medium in which the ray of light is should be a denser medium and it should pass through a rarer medium. Okay, another condition is that the angle of incidence, it should be greater than critical angle. Okay, so the two conditions, it should be inside a denser medium and the angle of incidence should be greater than the critical angle. Okay, so these are the two conditions for total internal reflection. Now mention the applications of total internal reflection. It's mainly used in optical fibers. Okay, so you can learn optical fibers. You can also learn it is used in prisms to bend light. Okay. Yeah. Now, applications of optical fibers, what are they? It is used in communication. So, what are optical fibers? They are just fibers that take in light and this light transfers data. Okay. So, let's say I want to transfer a signal from my place to a very far away place. If I have an optical cable and I can convert the data into light and then I can make the light pass through this long path. Okay. Guys, anyone here? Praju, I am here. Can't you see me? Yeah. Okay. And then what is myopia and hypermetropia? Myopia is just short-sightedness. Hypermetropia is long-sightedness. Okay. Yeah. Next, show that F is equal to R by 2. Derive the relation between focal length and radius of curvature of concave spherical mirror. Now, if you consider a concave spherical mirror, first thing, if this is the ray, I'll draw it with yellow. This is the incident ray. This is a reflected ray. And let's take red. This is the normal. So, the angle between these two, theta and theta, they should be equal, reflection. Now, alternate angles, right? So, if this is theta, this should also be theta. Similarly, if this much is theta, then this should also be 2 theta. They are also alternate angles. So, that's how you get the angles. Alternate angles. What are alternate angles? Angles like this. If this is theta, this will also be theta. Okay. And then this one from the center, this is radius of curvature, this is focus. Okay. So first here what I do, ma'am, some important questions. Come on, Praju, that is what I've been doing for the last 2 hours. These are all important questions. Sometimes all of you are just, I don't know. So what are the formulas? I mean, what should I do here? First thing, tan 2 theta should be how much? This triangle. So it would be MD by FD. Then I take the bigger triangle. From that I get tan theta would be MD by CD. Now if the angles are very small, I can write this as, if the angles are very small, I can write this as 2 theta is equal to MD by FD and theta is equal to MD by CD. This I can modify as 2 theta is equal to 2 MD by CD. This can I do? Yes. Now what I will do? I will just equate these two because it's the same. Both are 2 theta. So MD by FD will be equal to 2 MD by CD. Yeah. So these two cancel. So 1 by FD is equal to 2 by CD. So what is FD? It is F 2 by R. So 1 by F is equal to 2 by R. So F is equal to R by 2. Okay. Now students, in the derivation here is all going to be P. Okay. Instead of MD, it's going to be MP. It's just the same. D and P are very close points. So you can take it as MD or MP, whatever you want to. Okay. Yeah. D and P are close. Okay. Hi Nishu, where were you? I didn't see you in today's class. Good afternoon. Okay. Next is write a short note on total internal reflection. So what all should you write? You can write when a ray of light travels from a denser medium to a rarer medium, angle of incidence is greater than critical angle, and then it is totally reflected inside the denser medium. Okay. Now, since it's for 3 marks, you can also explain it with respect to this diagram. So you have, you have a denser medium, which is water, and then you have a rarer medium, which is air. Okay. And these light rays, they pass from here to here, here to here, here to here, and here to here. You can see in the first 2 cases, the angle of incidence is less than the critical angle. They undergo refraction. In the third case, the angle of incidence is equal to critical angle. So it is reflected 90 degrees. And then in the fourth one, angle of incidence is greater than critical angle. That is when it undergoes total internal reflection. Okay. Next is mention the sign convention for spherical mirror. You see, you have a mirror. Okay. You have an axis. You have the pole. Okay. So first point, all measurements are taken from the pole. Okay. All measurements are taken from the pole. Now, any measurement which is taken like this, which is towards the left, or you can say, if this is the direction of incident light. Okay. So any direction, any measurement taken in the opposite direction to the direction of incident light is negative. Now, if it is in the direction of incident light, it is positive. If the measurement is taken upwards, it is positive. If the measurement is taken downwards, it is negative. Okay. So those are the points here. You can read them. when I give you the PDF. See, if the angle is 90 degree, it is not total internal anything. Okay. So if the incident angle is equal to critical angle, then the ray is refracted on the surface itself. Okay. It is not total internal reflection or refraction. Okay. Next question. Yes, Praju, I did AC chapter important questions. You can watch the recording. Okay. Yeah. Draw the ray diagram of a compound microscope when the image is formed at a near point at least distant vision. So this is your object. You have the lens. Okay. What happens? The first ray comes. It is it passes, it is refracted. The second ray is refracted. And then you extend these two backwards. You get the image. This is a virtual image. Why do you extend them and get a virtual image? Because these two refracted rays, they don't meet anywhere. They will just go like this till infinity. When do you get an image? Image is formed only when two rays meet. Okay? If two rays meet, only then the image is formed. Here the rays are not meeting anywhere. The rays just go on and on forever. So you extend them backwards and you get a virtual image. Okay? Yes. Hello Praveen JK, you're late to class. Where were you? Oh, hello Silent Heart. So these are all students who were there in my class yesterday. Okay, that's how I know them. I mean, they've been there. It is infinite. What is infinite? Are you talking about the rays? Okay, next is wave optics. First 3 marker. State and explain Huygens principle. So what is Huygens principle? Huygens principle states that each point on a wavefront. Okay, before that, let me tell you what a wavefront is. Imagine I put a rock in water. Okay, what happens? Ripples are formed. These ripples are all wave fronts. So from the stone, waves are produced like this in all possible directions. Okay. Now what I'm going to do is I'm going to take points on all of those waves individually and I join them with a common point. That is my wavefront. So you can see here if I take points on all of these waves and I join them, I get a circle, which is my wavefront. It's called a ripple. Now imagine I have so many waves like this, straight waves. Okay. How do I draw a wavefront combining all of these? This is my wavefront. These are all my wavefronts. The green lines are my wavefronts. What are wavefronts? Wavefronts are lines joining multiple waves at the same phase or same properties. Okay. Now you can see the first point on Huygens principle. It states that every point on a wavefront is a source of secondary disturbance and secondary wavelets. So, if this is a wavefront, from here you get the next ripple. So, every wavefront produces secondary wavefronts. Okay? The new wavefront obtained at any later time is obtained by taking tangential surface in the forward direction to all spheres of secondary wavelets. Okay, so it's always in the same direction. So this is the first wavefront, secondary, third, fourth, fifth, they're all in that one direction. So if you look at this here, so this is the point source, just like I mentioned the stone. Okay, these are all ripples. Okay, and then all of these ripples are wavefronts. So you can see each ripple produces other ripples around it. See? And then the line joining those give you the secondary wavefront. Now here you can see there are points here. These points will produce more ripples. Okay, and when you join those, you will get the third wavefront. Now here again, these points will produce more wavefronts like this. And then these together will produce the next wavefront. So like this, it keeps on going, and after a long time, it starts to appear as straight lines. You can see the bend is reducing, reducing, reducing. After a long time, it becomes a straight line. Okay. Okay. Yes, guys, like Mardi, Silent Heart has come and started her job. Has anybody got their hall ticket? Yeah. That's Prem's question, okay? Not my question to you. Oh, hi, Naveen, the crazy. Naveen was also there yesterday. Students, all of you, please subscribe, okay? And like the video. And please share it to all your friends for writing exam 3. Okay? Let's just make sure everybody passes this time. Okay? Let's be, a group of students who want to, help each other and let each other study. See, I'm giving you classes for free. So the least you can do is send it to your friends. Let them also learn. Yeah? Yeah. Next, using Huygens principle, show that angle of incidence is equal to angle of reflection for a reflection of plane wavefront at a plane surface. Yeah, I know that, Praveen. I know without subscribing you can't chat. So there are some students who are not chatting, who are still watching. So I'm talking to them, okay? So I'm telling them to subscribe. Yeah? Raveen, I know you have subscribed. Okay. So this is a surface. Okay, you have to use Huygens principle to prove reflection of plane waves. Okay. So you have incident ray, reflected ray, another incident ray, reflected ray. So what I will do is, hi Vismaya. So what I will do is, I will draw a plane wavefront which is joining both the incident rays, another plane wavefront which is joining both the refracted rays. So this is your angle of refraction, this is your angle of incidence. Okay. Evaluation will be just like exam 1 and 2. Evaluation won't have any difference. Why should it have difference? Okay. That's why you should study early for your exams. Okay. So physics you finish today itself. Not anytime soon. When we have these sessions, you can meet us teachers. Okay, we'll have these, common sessions. Like we had one in JP Nagar. We have our offline center in JP Nagar. When the next one comes, we'll let you know. Okay. Hi, Sanjana. All right. Let's do this. Okay. Thank you, Arshad Gamer. Okay. Now, yeah, this is the angle of incidence. This is the angle of reflection. Okay. Thank you so much, anime fan. Please help me and support me by sending this video to all your friends. Okay. because I won't be able to continue this if the channel does not grow. Okay? Yeah. So it's your support that makes us grow. Otherwise, we have to stop it. So I don't want to stop it. I want to keep teaching all of you. So please, students, send this to all your friends. Support our channel. Okay? Make as many people as possible. Make them subscribe to the channel. Okay? So take all people's phones, subscribe to the channel. Okay? Yes? Yes. Okay, let's concentrate in class. So you have the incident wavefront, you have the reflected wavefront. So angle I, angle R. Okay. Now if, let's say V, okay, the alphabet V represents the speed of the wave. Okay. What does V represent? The speed of the wave. And tau represents the time taken by the wavefront to reach from point B to C. Do you see point B and C? Yeah. From point B to C. The time it takes and the speed it takes for the wave to reach from point B to C. You can see this is a surface. The wave is coming. It has to reach the surface. That time is Vt. So BC, the distance BC will be what? The distance BC will be V into tau. Okay. Now, by the time B reaches C, you can see that in the first wave here, A will be reflected back. Isn't it? See, do you understand that? By the time this reaches B, here this already reached the surface. Isn't it? So when the first ray reaches point B, the first ray reaches the surface, the second ray has already reached only point B. So by the time this B reaches C, this is reflected. So AE, which is a reflected ray, will be equal to BC, which is V tau. Yeah? You understand that? This is the surface. The first ray touches. When the first ray touches, the second ray has only reached here. When the first ray reflects, the second ray touches. That is how AE will be BC, which is V tau. Okay? And then angle ABC and CEA is 90 degree. So this proves to us that angle I is angle R, because you prove that triangle EAC, this triangle and which triangle? And triangle BAC, both of these are congruent. How did I prove? Two angles are 90, two sides are V tau. So that's how I prove it, isn't it? To prove it, AC is common to both. Okay, AC is the base. AC is common to both the triangles. It has 290-degree angle, and BC and AE both are V tau. They are also the same. So which means the triangles are congruent. If the triangles are congruent, then angle I should be equal to angle R. Okay? Yeah, I can see some people are flirting to each other in the group. Okay? You can call him bro itself. That's enough. Alright. Naveen, listen to my class. Okay? My God, Arshad, you want proof? We'll ask her to upload her Aadhaar card in the chat. Shall we? Did you all start preparing for exam 3? Yeah? Yes? If you all started preparing for exam 3, put some fire in the chat. Some quick energy. Fire emojis in the chat. Quickly. Okay. Write the condition for constructive interference in terms of phase difference and path difference. So phase difference phi is 2n pi. Path difference is n lambda. Okay. Now for destructive interference, it is 2n plus 1 pi, and then path difference is 2n plus 1 lambda by 2. Okay. It's okay, Arshad. Yes, guys like Madi, listen to Silent Heart. Okay, next is interference and diffraction. What is the difference between interference and diffraction? So interference is where, two light rays come, okay, they meet, they produce a third light ray. So let's say, there is a light ray, there is another light ray, they both interfere together, you will get a big light ray. But there's one more condition, one more case. If this is the first light ray and the second light ray is in opposite phase, when they join, what happens? You will get nothing. It will be just darkness. Okay? So both of these can happen in interference. Okay? So it is a phenomenon of modification in the distribution of light. So when two rays come, the distribution is modified and you get the output. It is a superpositioning of two or more light rays. Alright? Yeah. Now, interference fringes are due to superposition of waves emerging from different sources. Interference fringes are equal. Intensity of all bright fringe is the same. Blah, blah, blah. What is diffraction? Okay, some of you might be thinking, I'm talking about diffraction for a long time. Let me explain. Imagine I have a slit here. Okay. I have a light ray coming. It's straight. But this light ray now has to pass through the slit. So what happens? It bends. See? This is diffraction. Diffraction is the bending of light ray when there is an obstacle. Okay. That is called diffraction. Okay. So it is the bending of light around an obstacle and entering into its geometrical shadow. Alright. So diffraction fringes are due to superpositioning of secondary waves. Bands are of unequal width. All of that. You can learn 2 or 3 points. Okay. Now resolving power. You can just go through methods of increasing resolving power. It is by using short wavelength, high refractive index between object and microscope. Okay. Mention any 2 uses of Polaroids. Polaroids are used to produce plain polarized light to analyze the polarized light. It's used in sunglasses, 3D pictures, and all of that. Okay. Last point in waves is Malus law. So Malus law just tells us that, see, if you have a polarizer. What is a polarizer? Something that polarizes light. What do you mean by polarizing light? See, initially light has vibrations in all directions. Okay? Light is like this. So a polarizer allows only one direction of vibration to pass through. So after it passes through, it becomes like this. Or like this. Any one direction of vibration only passes through, the rest is cut. That is how a sunglass works. See, when you wear a sunglass, light intensity reaching your eye reduces. That's because all the other directions of light are removed. Only light in one particular direction, which means vibrations of light waves in one particular direction reach your eye. Okay. And then there is an analyzer. Okay. This analyzes the wave and then it comes out like this. Okay. So the intensity of light passing through this analyzer is equal to I0 cos square theta. What is I0? I0 is the intensity of incident polarized light and theta is the angle between the pass axis of polarizer and analyzer. Which means that this is the pass axis. The angle between those two is called theta. Okay. Okay. Next is dual nature of radiation and matter. There are 2 types of electron emissions. What are they? Thermionic, photoelectric, field and secondary. Now, what are the experimental observations or laws of photoelectric effect? Now, for a given photosensitive material and frequency of incident radiation, the photoelectric current is directly proportional to the intensity of incident light. Yeah? So, what is happening here? You have an incident radiation coming, it's going to hit a metal surface, electron is emitted. Yeah. So the frequency of incident radiation and the amount of emission, electron emission. So the saturation current is proportional to the intensity of incident radiation. Okay. Also, the minimum cutoff frequency of the incident radiation, which is called the threshold frequency, below which there is no emission. Which means, see, the ray that's coming, it should have a certain frequency. Only if it's higher than that frequency, electrons can come out. If it's not higher than that frequency, electrons won't come out. See, like, to some very naughty students, not students like you, but, some naughty students, only if we shout at them and scold them, they will sit properly. Otherwise, they will not care. Right? Right? Similarly, only if the frequency is strong enough, electrons will come out. Otherwise, electrons won't come out. So that is the threshold. Yes, Sinchana, I will put PDF, but please do attend the lesson and then look at the PDF. Okay? Okay. So for a given photosensitive material, there exists a certain minimum cutoff frequency of the incident radiation called the threshold frequency, below which no emission of photoelectrons electrons take place. That is what I just explained. Now, above the threshold frequency, so imagine the radiation coming in, it is above the threshold frequency. Okay? Or the maximum kinetic energy of the emitted photoelectron, it increases with frequency of incident radiation. Photoelectric emission is also an instantaneous process. Okay, that means the moment the frequency comes and falls, electron is emitted. It's an instantaneous process. Okay. Yeah. Now, whatever energy of the incident radiation comes, some of it is used for the electron to be knocked out. The rest is used as kinetic energy. Okay. That is why whatever radiation comes in, okay, some of it is used as kinetic energy and some of it is used as phi, which is work function, which is to emit the electron. Okay? Yes. Now, properties of photons. Photons are neutral. They don't have any charge. Okay? Each photon has an energy of h nu. The momentum of the photon is h nu by c. Photons travel with speed c in vacuum. They're neutral and their total energy and momentum are conserved. Okay? Next question. What are matter waves or de Broglie waves? Write the expression for de Broglie wavelength. Okay? So the waves associated with a material in motion are called matter waves. So the wavelength is h by p, which is h by mv. H is a Planck's constant. P is equal to mv is the momentum of the moving particle. Okay. So the wavelength of de Broglie waves is given by lambda is equal to h by p. Okay. So outline the Einstein's explanation for photoelectric effect or write Einstein's photoelectric equation. Explain the experimental results for photoelectric effect on the basis of Einstein's photoelectric equation. So students, this can come as a 3 marker or a 5 marker. Okay. So depending on if it's 3 or 5, you have to write down the number of points. If it's for 3, you write down those many number of points. If it's for 5, you write down a little more. Okay. Bye, silent heart. Take care. You're going to have lunch. So who will ask my students to like and subscribe if you go? Okay. So the maximum kinetic energy is h nu by minus phi naught. This we already discussed. Now, according to Einstein's photoelectric effect, kinetic energy depends linearly on frequency. As frequency of the incident radiation increases, the maximum kinetic energy of the emitted electron also increases. Kinetic energy is independent of incident radiation. So all these points you can read through when I upload the PDF because I've explained it so many times. Okay. Next, let's look at atoms. Okay. So in atoms, the first important thing is Bohr's postulate of a hydrogen atom. Okay. So what are Bohr's postulates? The first thing, you have an electron. Okay. So this is atom. This is the nucleus. You have orbits. Okay. So electrons revolve around in certain stable orbits. They don't radiate any energy. They're very happy there. They're stationary there. Okay. So electrons move around in stable orbits. That's the first point. Next, what are these stable or stationary orbits? They are orbits where the angular momentum is the integral multiple of h by 2 pi. Okay. So h is the Planck's constant. Now, sometimes these electrons, they can transition. So if these are two energy levels, an electron that is in a lower energy, so I've just drawn it as a straight line, it's actually the curved orbit. Okay. So an electron here, if it gains energy from some external radiation, it will feel like it has a lot of energy. So what it does, it will go up to the higher energy level and it will stay there. But once it reaches a higher energy level, it comes to know that, oh my God, I don't have the energy to stay here forever. I have to come down. So what happens? It comes back home. Because it just went there with, some overconfidence. But once it reaches there, it realizes it cannot stay there. So it comes back. But when it comes back, the extra energy that it had, it just releases it as h nu. Okay. So now what is this h nu? This h nu is equal to the difference in energy levels. Okay. That is the next point. H nu is equal to E initial minus E final. Okay. It's usually final minus initial because, final will be more. Okay. E initial, let's say this is a higher energy level. So higher minus lower. Okay. Yes, students, lunch, I will give you a break, 10 minutes. Okay. After we finish 3 markers, we'll have a break for lunch and then we will do 5 markers. Okay. Next is the limitations of Bohr's model. So main limitations of Bohr's model was that it is only applicable to hydrogen and hydrogen-like atoms, and it did not explain the hyperfine structure of hydrogen atom. It did not explain spectral lines nor the wave nature of electrons. Okay. Next is de Broglie explanation of Bohr's quantization of angular momentum. Okay. So according to de Broglie, 2 pi Rn, okay, 2 pi Rn should be equal to n lambda. So from that, lambda is what? H by mvn. So 2 pi Rn will be n into h by mvn. mvrn is nh by 2 pi. So L will be mvrn divided by nh by 2 pi. Very easy. Next, for nuclei, first we will look at what is mass defect. What is mass defect? It is the difference between the sum of masses of nucleons forming the nucleus with respect to the mass of the nucleus. What does that mean? Okay, imagine you have 5 protons and 5 neutrons. Okay, the whole mass of the nucleus and the mass of the 5 protons and 5 neutrons individually added would not be the same. There is a small defect there. That is mass defect. If you look at this formula, look at this. Z into mass of protons, okay, which is the number of protons into mass of protons, plus A minus Z is the number of neutrons into mass of neutrons. That should actually be same as the mass of the whole nucleus, right? But no. If you subtract it with the mass of the whole nucleus, you will get a small value which is called the mass defect. Okay? So that is the mass defect. Now, a binding energy, define binding energy and draw binding energy curve and write main features of binding energy. So, binding energy is defined as what? The minimum energy required to split the nucleus into its corresponding nucleons. Okay, and this is how binding energy curve varies. Okay, so you can see for different elements how it varies. So the binding energy per nucleon of is lower for all the nucleuses that have at mass number less than 30. So somewhere less than 30, and heavy nucleus is greater than 170. The binding energy per nucleon is practically constant. You can see it's almost a constant, and it is independent of the atomic number for nucleus between 30 to 170. And the curve has a maximum at 56, somewhere at 56 it has the maximum. And what else? When A is 238, it is 7.6 MeV. Okay. Next is properties of nuclear forces. They are strong forces, short range, saturated. All of these you will know. Radioactive decay law, I don't think you need to know that, but you can just go through that. Next is nuclear fission and nuclear fusion. So, what is nuclear fission? It is the splitting of heavy nucleus into lighter nucleuses. Fusion is the combining of two lighter nucleus to form a heavy nucleus. In both, energy released is more when heavy breaks down into light. The other one, energy released is less. It takes place at low temperature, it takes place at high temperature. Yeah, all of that. Okay. Next is semiconductors. What are semiconductors? There are two types of semiconductors: intrinsic semiconductors and extrinsic semiconductors. So what are intrinsic? They are pure. Extrinsic is doped. So in intrinsic, number of electrons and holes are all the same. In extrinsic, free electrons and holes, they're unequal. So conductivity will be less for intrinsic, it will be more for extrinsic. Now in extrinsic, you can divide it into two. Okay. So extrinsic can be divided into N-type and P-type. Okay. So P-type is when you have only a trivalent impurity, which means if the pure semiconductor has 4 electrons, you bring 3 more electrons. So in total, you have only 7 electrons, but you need 1 more. So the 8th is a hole, which means there's an extra hole. So holes are a majority charge carrier. In N-type, you have 4 electrons in the pure. The dopant has 5 electrons. So in total, you have 9, which means you have an extra electron. So electrons are the majority charge carriers. Next is, what is forward biasing? Draw the VI graph. What is reverse biasing? Draw the VI graph. So you can see in forward biasing, initially till the threshold voltage, it does not conduct. But after the threshold voltage, it conducts. Even in reverse bias, initially it does not conduct, but after the threshold, it conducts. But the main difference is, in forward bias, P-type is connected to positive, N-type is connected to negative, and the current flows because of majority charge carriers. But in PN junction reverse biased, the current flows because of minority charge carriers. Okay, so that is the main difference between P forward and reverse. So these are all some 3 markers. Now we will continue after 15 minutes with 5 markers. Resume back at 1:45 for 5 mark questions. Okay. So students, quickly I want all of you to go have your lunch and come, and then we will continue. Okay. Yes. Okay. Um, yes, are you all ready for class? Hello. So now, as I said, we're going to do 5 markers. Students, no spamming in the chat, please. Yeah, can you all let me know if you're all ready for the class? Hello, Afira. Okay, now, first question is to derive an expression for electric field at a point on the axis of an electric dipole. Okay, so let's consider the figure. You have an electric dipole consisting of minus q and plus q. It is separated by a distance of 2a. Okay, it is separated by a distance of 2a. Now, let P be a point. Let P be a point on the axial line at a distance r from the center O. So, the center of the dipole is O. Host 46, Afira, Salenhard, all of you ready? Okay, center is O. So, A. So, I will put P here. So, R. Okay, let's just put it here. So, R is the distance. Hi, Samarth. Yes, R is the distance from point P to the center of the dipole. Okay, now first, let us look at the electric field at point P because of charge plus Q. Okay, so what is the distance between plus Q to P? The whole thing is R. So this is A, this is A. So isn't it R minus A? So E because of plus Q will be, hi Sri, 1 by 4 pi epsilon naught Q divided by R minus the whole square into P cap. Yes, because it's in the direction of P. Now E because of minus Q will be how much? 1 by 4 pi epsilon naught Q divided by R plus A, right? Because it's R plus A from P to minus Q. R plus A the whole square P cap. Okay, so that is how I get these two equations. This is done. Now the resultant electric field will be how much? The resultant electric field. So electric field because of plus Q will be in this direction. Take a different color in this direction. But the electric field because of minus Q will be towards minus Q. It will be in this direction. Isn't it? From a positive charge, field lines always move out. From a negative, field lines move in. So the resultant electric field at point P will be E plus Q in this direction, E minus Q in this direction. So the resultant will be subtracting E plus Q and E minus Q. Right. So you have to subtract E plus Q and E minus Q. Minus Q. Okay. This is also minus. So you take the common terms outside. What are the common terms? Q divided by 4 pi epsilon naught 1 by R minus A square minus 1 by R plus A square P cap. Okay. Now let's simplify the expression. So what does it mean? You take the LCM. So you cross multiply. Okay. You will get R plus A the whole square minus R minus A the whole square divided by R square minus A square. So A plus B the whole square is equal to A square plus B square plus 2AB. So that's how you get R square plus A square plus 2RA minus R square plus A square. So A minus B, the whole square is A square plus B square minus 2AB. Okay. So you solve it. You will get 4RA. Okay. Now E will be equal to, what I will do, I will split 4RA into 2 into 2RA. So I can get 2AQ term from there. So what will 2AQ be? 2AQ, what will 2AQ be? 2AQ will be equal to P. What is P? P is the dipole moment. Okay. So P is the dipole moment. So E is equal to 1 by 4 pi epsilon naught 2PR divided by R square minus A square the whole square P cap. Okay. So this is electric field on the axial line of an electric dipole. Okay. Yes. Now if it's a very short dipole, okay, that means the point P is very close. So let's say R is very much big compared to A, then you can just ignore A. So instead of R square minus A square the whole square, you can write it as R square the whole square, which is R raised to 4. So now this equation will become this will become 1 by 4 pi epsilon naught 2PR by R raised to 4 P cap. R and R raised to 4 will cancel, and hence you will get E is equal to 1 by 4 pi epsilon naught 2P by R cube P cap. Okay? Yeah? Okay. Next question. Derive an expression for electric field at a point on the equatorial line of the electric dipole. So what does this mean? This means that you have a dipole. In the previous case, you took a point P on the same line, which is on the axis. Here you take a point P at the equatorial. Okay, that's the difference between the two. So now let's say this is your minus Q, this is your plus Q, this is your P. Now at point P, electric field because of minus Q will be towards minus Q. Yes, field lines always go towards the negative charge. Now how about because of plus Q? Because of plus Q is along this line, right? It's along this line. So it would be away from plus Q. Isn't it? Wouldn't it be in this direction? Because field lines always move away. So it will take these two directions. That's how I get E1, E2. Okay? See, I cannot, I don't know what the question paper is going to be because I'm not part of any of that. But what I can give you is I can give you all past year questions, important questions, the most expected questions. That's the only thing I can give you on a day before the exam. So I don't have time to teach you line by line. So hopefully if these questions come, you will be able to score very well. Okay? It all depends on how the exam questions come. Let's just hope for the best. Okay? So right now what you can do is you can focus on important questions and learn that. That's the only thing you can do on a day before the exam. Okay? Yes? Alright. So now see the electric field is in two random directions. So I will resolve it into X component and Y component. Okay. So now Y component, you don't have to consider, no, not Y component. Sorry. What I will do is I will just take the resultant of these two vectors. Okay. So E is the resultant of the two vectors. Now what I will do, I will do the derivation. So this distance 2A, this I will take it as R. Hi Jai Shri Ram. Hi Lalita. Okay. So now what I will do, I will write down the electric field because of plus Q. The electric field because of plus Q is 1 by 4 pi epsilon naught Q divided by, what is the distance between plus Q to P? If this is A and that is R, shouldn't this be square root of R square plus A square? Yeah. So this should be R square plus A square raised to 1 by 2. So this will be R square plus A square, the whole raised to 3 by 2. Okay. Because it is electric field. Next is E of minus Q. 1 by 4 pi epsilon naught. Again, Q divided by R square plus A square, the whole raised to 3 by 2 minus R cap. They're both in two different directions. So, yes, you will definitely pass with this video. This is passing package. You have to watch all 3 videos. Yesterday there was a video, today, and then tomorrow also I will upload one with numericals and all that. Okay. Okay, R cap and minus. But students, if you just watch the video and go, you will not pass. You have to study what is there in the video. So do the derivations with this and study with the video. Okay. Yeah. So that's how I get plus Q minus Q. Now, the E plus Q and E minus Q, they are components perpendicular to the dipole. So these are horizontal components. So there will be a cos theta component here. Okay. Since they're horizontal components, there will be a cos theta component. So total electric field E will be E plus Q cos theta plus E minus Q cos theta. Okay. And then you add them, you will get the answer. So when you add them, you will get this term. So E will be equal to 1 by 4 pi epsilon naught 2AQ R square plus A square raised to 3 by 2 P cap. Okay. Okay. So E is equal to minus 1 by 4 pi epsilon naught P by R cube into P cap. Okay. Let's look at the next question. State Gauss law in electrostatics. Derive an expression for electric field at a point due to a uniformly thin, long, straight conductor. This question we already discussed for 3 marks. This is a similar question for 5 marks as well. Okay. So for 5 marks, what will you write? Same thing, the steps. What is it? Phi is equal to E into del S. Del S or EA. Okay, anything is fine because in 3 markers you might have seen that this is equal to phi EA. Okay. Now phi is equal to E into A becomes 2 pi RL. Okay. Phi is also Q by epsilon naught. Q is lambda L. You combine everything, you get E is equal to lambda divided by 2 pi epsilon naught R. Okay. So the reason I'm going fast here is because we've already discussed this in 3 markers. Okay. Next one. Derive an expression for electric field at a point due to a charged spherical shell using Gauss law. So what you have a charged spherical shell. This is at a distance R, Q enclosed, another shell at a distance R. So you have to find out the electric field at a point due to the charged spherical shell. Okay. Using Gauss law. So it's the same steps. Students, same steps. So phi is equal to EA. But here what is A? It is a sphere. So it is 4 pi r square. Okay. So phi is also Q by epsilon naught. So E into 4 pi r square is equal to Q by epsilon naught. So E is equal to Q divided by 4 pi epsilon naught r square. Now if it's the outer sphere, then what will it be? E will be Q divided by 4 pi epsilon naught r square. This is also same as sigma by epsilon naught. So you will write it as sigma is Q divided by 4 pi r square. Aishwarya, the PDF for last class is there in the Telegram channel. Okay, I've uploaded it yesterday. You can just check, yesterday night's chat, it is there. Today's PDF is not uploaded yet because I'm still teaching it, right? So after the class only I will be able to upload it. Okay? You only want PDF, you don't want lectures. So then we can just make PDFs and give you, Okay. Next is obtain an expression for electrostatic potential at a point due to an isolated point charge. So let's say you have a point charge here. Okay, the point charge is plus Q. Okay, the point charge is plus Q. Yes. So let's consider a point plus Q. Okay, and another charge is brought together. Video is lagging. Is my video lagging? Lagging. Okay, let's do it. I don't think it's lagging. So consider a point A. Okay, a point A which is at a distance x from O. Okay, so the electrostatic force on any unit positive charge at A is given by E is equal to 1 by 4 pi epsilon naught Q by x square. Q by x square. Okay, so what will dW be? dW will be E dot dx, which is E dx into cos 180 because it's anti-parallel. So it is minus E dx. Now you just have to find out the work done. So what is the total work done? Total work done in moving unit plus charge from infinity to the point P is W is equal to infinity to R dW, which is infinity to R minus E dx. What is E? E is 1 by 4 pi epsilon naught. So infinity to R minus 1 by 4 pi epsilon naught Q by x square dx. Okay, so I take all the constants outside. Minus Q divided by 4 pi epsilon naught minus 1 by x R into infinity. So this will be W is equal to Q divided by 4 pi epsilon naught 1 by R minus 1 by infinity. So W is equal to Q divided by 4 pi epsilon naught R. So W is the same as V. So you will get V is equal to Q by 4 pi epsilon naught R. Okay. Thank you, Arshad. Okay. So for my hard work, can you please subscribe? Ask all your friends to subscribe, like, and share to my channel. Yeah. Obtain an expression for potential energy of an electric dipole placed in a uniform electric field. So what do we have to obtain? We have to obtain an expression for the potential energy of a dipole inside an electric field. Okay. So let's consider a capacitor of capacitance C. A. Potential energy for dipole. There is something wrong here. I think there's a page missing here. Okay. So when I upload it as a PDF, I will make it correct and send it to you. Okay. Yeah. So let's consider a capacitance. A capacitor which was having a capacitance C. Okay. And the potential difference V is applied across the capacitor using a battery. And you are going to find out, the process that you're going to consider is you're you're transferring charge from one conductor to another. Okay. So the potential difference between the conductors will be what? Q by C. Okay. You're transferring charge from one conductor to another. Okay. Now what will you do? If you find dW, what will dW be? dW will be V bar dQ. Yes. V bar is what? Q by C. So you will get Q by C dQ. Now let's integrate. Basic integration. So you integrate it with respect to 0 to Q. So W is the integral of dW, which is equal to Q by C into dQ. Okay. In this 1 by C I take outside. So 1 by C Q dQ. Okay. So W will be 1 by C Q square by 2. Do you get that? 1 by C Q square by 2. And then you have Q and 0. So Q square by 2 minus 0. W is equal to Q square by 2C. Okay. Yeah. Now, the work done is stored as electrostatic potential energy. Therefore, U is also Q square by 2C. Now, you just rearrange the formula. Q is equal to CV. And you will get U is half CV square and U is half QV. Okay. Okay. Yes. Let's look at the next question. Arrive at the expression for equivalent EMF and internal resistance of two cells connected in series. So this question, students, we've already discussed as a 3 marker. This question can also come as a 5 marker. So I'm not going to discuss this question because the same question we discussed as a 3 marker. Okay. So it is just the same thing. And then another question. Okay, I've smiled. Okay. Yeah. Arshad, there is one more lecture before your exam, which is going to be today night or tomorrow. So in that video, I will be doing numericals. Okay? Yeah, see, my students are more updated. Movies Ka World has already given you the reply. It's today night or tomorrow night. Yes. Okay? Yeah, the name of the video is some important question something. What is it? Second PUC most repeated questions. In that we will discuss numericals, the second part. Okay? Yeah. So next is deduce expression for equivalent EMF and equivalent internal resistance when two different cells are connected in parallel. Ma'am, how old are you? How old do you think I am? Okay? This also I'm not explaining because the same thing I've explained already as a 3 marker. Okay? Okay. Deduce the condition for balancing condition of a Wheatstone's bridge using Kirchhoff's law. Okay, let's look at this one. So you have a resistor, 4 resistors. Okay. 4 resistors, and then a current I comes, it goes as I1, I2, I3, I4. So students, in different derivations, the sign conventions will be different, okay? So sometimes, I1 will be different, I2 will be different, I3, I4 will be different. So yesterday's class, in that particular derivation, in the picture that I took, it was I1, I2. So that doesn't matter. So if you understand the concept, whichever one is I1, I2, I3, I4, you should be able to do it. Okay. So learn any one. Okay. So let's first take this loop. Alright. Do I have a picture somewhere here? Yes, I have a picture somewhere here. Okay. So here, first thing, what we're going to do is, at node D and at node B, I'll write down the currents. Okay. So at node D, what will happen? At node D, what should happen? I1 comes and IG comes. So this I3 should be what? Yeah. So this I3 should be equal to I1 plus IG. Okay. And I4 should be what? I4 should be I2 and IG comes. So it's going to be I2 minus IG. Okay. So, and then what I'm going to do is, I'm going to take the balancing condition of a V-Stone's bridge. Okay. So at the balancing condition, the galvanometer should deflect. Alright. So galvanometer would show deflection only when the resistances are not, equal. So I'm taking balancing condition, which means resistances are equal. In that case, what happens? Ig is equal to 0 for balancing condition. So balancing condition. So in that case, I4 will be the same as I2. Okay. And I3 will be the same as I1. Do you understand that? Because I take Ig to be 0. Yeah. Okay. So, yeah. Next, you have to apply Kirchhoff's loop rule. So here what I'm going to do is, like this. So, if I'm going in the direction of the current, I'll take it as negative. So, I'm starting from here. Okay. So, initially I'm going minus I1 R1 plus Ig is 0 plus 0. And then I come back. Okay. When I come back here, I am coming in the direction opposite to the direction of the current. So, it becomes plus I2 R2. This is 0. So, I will get I2 R2 is I1 R1. Now, for the second loop, let me start from B. Okay. So, B is like this, like this. So, B is in the direction opposite to in which I am going. Right. So, it's going to be, this is wrong, minus I4 R4 plus 0 and then minus I3 R3 is 0. So, from this I will get, I4 R3 is I4 R4 is I3 R3. So, I already know I4 is the same as I2. I3 is the same as I1. Okay. So, if you substitute in every, all of it, you will just get I1 R1 divided by I1 R3 is equal to I2 R2 by I2 R4. So, you divide all the i's, you will get R1 by R3 is R2 by R4. And this is the balancing condition for a V-Stone's bridge. Okay. Next is to deduce the expression for magnetic field on the axis of a current carrying loop. Okay. So if you all score well in exam 3 and let me know in the comments, then I'll tell you. Okay. Viveka, World and Praveen. So you have to score very well and comment. Let me know in the comments how much you scored. Yeah. Ma'am, what's for lunch? Nothing. After class, I have to go and eat something. Okay. Yeah. Biryani in Praveen's home. So Praveen will invite all of us for biryani. Okay. So if this is a loop, okay, we have to find out the expression for magnetic field at a point P. Okay. So I have a loop. I have a point P. Okay. And then you take a part dl. I take a small element dl. Okay. The small element dl, I take it from point P. Okay. From point P to dl. Alright. Now what I will do is at point P, it will have a magnetic field. So the magnetic field is going to be in a random direction. So I am going to resolve it into x component and y component. Okay. Now I will take one more case. So if I take a small element at the bottom of the loop and I draw a line to P, then its magnetic field will be in the bottom direction. Now it will also have a y component and an x component. So the y components are both dby cos alpha or cos theta. Here also it is db cos theta. Okay. Since they are both equal and opposite, what happens? They cancel off. So you don't have to bother about the y component now. Okay. So the y components, they cancel out. Okay. Now what happens to x components? There is a db cos theta because of the top part and bottom part. So you have to add the db cos theta terms. Okay. Is that clear? Is the picture clear? Okay. So dby and dby, their cos thetas, they cancel out. Okay. Now you can just use Biot-Savart's law. Okay. And you will get dB is what? Nu 0 by 4 pi IDL R square. Now what I will take is the total magnetic field. Okay. The total magnetic field will be equal to dBx only. Okay. Why dBx only? Because dBy terms cancel. So dBx means dBx cos theta. So this I will substitute as dB. So this will be dBx will be dB cos theta, which is nu 0 by 4 pi IDL R square cos theta. So cos theta is equal to what? I will take this triangle here. So cos theta will be what? This is x. Sorry, this is r. So cos theta will be x divided by r square plus x square from trigonometry. Yeah. Also r square is what? R square plus x square. Basic Pythagoras theorem. So if this is r, x, this is r, then this is r square. No, r square plus x square. Okay. And then you just have to keep substituting. Okay, you just have to substitute nu 0 by 4 pi, which is IDL r square plus x square into x into r square plus x square, and then you join the terms. Okay, so this will be the final expression. Students, a simpler version of this derivation I did in my last class, yesterday's class. Okay, so when you're studying this derivation, you can look at yesterday's class because that derivation is more simpler. This is more longer. It's for 5 marks, but still you can use the same thing from yesterday's class for 5 marks. Okay. So please go through yesterday's video for this derivation. Okay. Yeah. Next question is derive an expression for force per unit length on two infinitely long, thin, parallel straight current carrying conductors and hence define ampere. Okay. So you have two wires and they will have a force F1 and then a force F2. Okay. So this will be B2, B1. It's the magnetic field. the distance between them is d. Okay. So this also I have done it very clearly in the last video, but I'll explain it once again here. So magnetic field at B, the magnetic field B1, okay, B1 at any point on the conductor is because of current I1. Okay, magnetic field B2 is because of current I1. So B1 will be equal to mu 0 I1 divided by 2 pi r. Yes. So the force experienced by the conductor is going to be equal to B1 I2 L sin theta. Okay. So it is going to be equal to B1 I2 L, which is equal to mu 0 I1 by 2 pi r I2 into L. So the final answer will be mu 0 I1 I2 L by 2 pi r. Okay. Now the force towards conductor P will be what? F1 will be mu 0 I1 I2 L divided by 2 pi r. So F1 is equal to F2. Now if you want to find out the force per unit length, you just have to divide the whole thing by L. So F1 by L is equal to F2 by L, which is equal to mu 0 I1 I2 divided by 2 pi r. Okay? Yes. Muskan Khan, how was your Bakrid? Okay, so from this we have to define 1 ampere. So what is 1 ampere? You just have to take every quantity as 1. Okay, so you have to take I1 as 1 and the distance between the conductors is 1. Okay, so you're just taking infinitely long conductors that are carrying equal currents. So the currents are 1 amps each and the distance between the two wires is 1. So you will get the answer as 2 into 10 raised to minus 7. Okay. So 1 ampere is defined as the constant current which when maintained in each of the two infinitely long straight parallel conductors are negligible cross section and placed 1 meter apart in vacuum causes each conductor to experience a force of 2 into 10 raised to minus 7 Newton per meter length. Okay. Okay. Next is construction and working of a galvanometer. So what is a galvanometer? It is a device that is used to detect the presence of electric current. And what is the principle? The working of a moving coil galvanometer is based on the principle of electromagnetic induction. Okay? Especially the torque experienced by a current carrying coil in a magnetic field. Alright? Okay. Now to construct it, you have a rectangular coil. Okay. You have a coil of many turns and you place it inside a magnet of North Pole and South Pole, and you enhance its magnetic field strength. You have, okay, this coil is connected to a scale. Okay. So every time there is a movement, the pointer will move and the pointer is put on a scale. So you will be able to see the value. Okay. Now, when current I flows through the coil placed in the magnetic field, the coil experiences a torque due to the interaction between the current and magnetic field. And that is given by torque is equal to NIAB. Yes, coil in magnetic field experiences torque. Very good, Praveen. Okay. Okay. Now, the torque of the spring is equal to constant K times phi. Okay. This constant K is called as torsional constant. It is basically the restoring torque. So, if it moves, it has to come back to its initial position. Okay. So, now at equilibrium, what happens? K phi will be NIAB. Yes. K phi will be NIAB. Now phi will be what? NAB by K into I. That's all. Okay. Next is the refraction at a spherical surface. What do you mean by can we change the restoring torque? So restoring torque is basically a force by which it comes back to its initial position. How can you change it? Hacker. Can you actually hack something? Okay, so refraction at a spherical surface. Now, before deriving the lens maker's formula, you need to use this formula to do spherical surface refraction. So the formula is N2 by V minus N1 by U is equal to N2 minus N1 by R. Okay, so it is the radius of curvature when light passes from one medium to another. So N1, what is N1? N1 is the refractive index of the object medium. N2 is the refractive index of the image medium. And U is what? U is the object distance, V is the image distance, R is the radius of curvature. Okay. Next, very important formula, derive lens maker's formula. Okay. Passing package, I've already done a video, Rise School Gamer. You can just go to Vedantu Karnataka channel, search for passing package physics. I think I've done it for exam 2, but it's going to be useful for exam 3 as well. Okay. Why are you depressed for exam 3, rocker? Yeah. Exam 3 is just another exam, but your last exam. Okay, so don't waste time. You have today and tomorrow. Study properly, you will definitely pass. Okay, I trust that all of you will pass if you study today and tomorrow properly. Okay, don't be worried. Just make sure you are going to utilize all the time that you have now. So you have like 1.5 days. So instead of sitting and worrying, say you have 1.5 days. Let's make the most use out of it. Let's be the most productive for the next 2 days. So sit and study. Don't waste time on social media or going out with friends and all. You can do all that after your exam. For the next 2 days, sit and study. 1.5 days actually. Sit and study, crack your exam and let me know in the comments how it went. Okay? Why? Why do you all be depressed? Yeah. So this is a lens. Okay. I have an incident ray. Now imagine this lens has only one surface. Okay. This is the lens, right? So imagine the second surface is absent. The lens has only one surface. So where will you get the image? Let me look at what notation I have used. Image is, object is U, image is V, DI. Okay, let's look at this picture first. So this is the first surface. So imagine this second surface is absent. Only one surface is there. Then the object will produce an image at I1. Okay, that is what you see here. See, straight I1. That is if the second surface is absent. But in reality, the second surface is there. So now what happens? Whatever was produced because of the first surface, now that image, which is I1, that image I1 is now going to be refracted by the second surface. So I1 is going to be the object for surface 2. Okay, I1 will be the object for surface 2 and I1 is going to be refracted as I. Okay, so first, the things that you need to know. First object is O. Second object is I1. Okay, first image is I1. Second image is I. Okay. Supreet, you can definitely try. Yeah, you can definitely try. You can try looking, try. And it all depends on the questions. Okay. So if all questions come from this, you will definitely be able to score more. So all of you should go through the MCQs also. Okay. I've done a video on 100 plus MCQs. All of you should go through the MCQs also. Okay. And only then go for your exam because you don't have to lose, 10 to 15 marks you get for MCQs. All right. So now let's do the whatever we have to do. First, formula. So N2 divided by V, okay, minus N1 divided by U is N2 minus N1 by R. Okay. Now, for the next surface, N1 by V minus N2 by V dash is N1 minus N2 by R. And then what you can do, you can just add the two equations, you add them, and then you will get the final equation, which is the Lensmaker's formula. 1 by F is equal to N2 by N1 minus 1 times 1 by R1 minus 1 by R. Okay? Yes? So here, if you can understand the first part, which is the object and which is the image, then the rest is fine. You just have to substitute that for surface 1, for surface 2, and then add them. Okay? Rocker, watch all the videos. Yeah? Watch all the videos. Watch the videos for 100 plus MCQs also. For physics, I've done that. You can watch that also. If you get MCQs correct itself, you're half sorted. And then study all 3 markers, 2 markers, 5 markers. Numericals, tomorrow I will be doing a video, tomorrow or today night. So that also you can do. Okay? So there are 2 lenses. So this question is, derive the expression for combination of 2 thin lenses in contact. Okay? So 2 thin lenses in contact. Let's say there's L1, L2 are the 2 thin lenses. So what will we do? So for the first lens alone, 1 by V minus 1 by U is 1 by F1. For the second lens also 1 by V minus 1 by U is 1 by F2. And then you add these equations. And then you add these 2 equations. Okay. When you add these 2 equations, you get 1 by F2 plus 1 by F1. Okay. So 1 by V minus 1 by U is 1 by F1 plus 1 by F2. So you will get the final answer as 1 by F is 1 by F1 plus 1 by F2. Okay. My earnings from YouTube. You think I'm earning lakhs from YouTube? Students, I'm just doing these videos just for all of you. Okay. Because I want you all to clear exam 3. It's not that we're earning anything. See, if 12 people watch a class, you don't earn anything. Okay. Yeah. So this is just for all of you. Because we have a lot of students requesting for exam 3, pass package, exam 3, that, this and all. So this is a channel where we give you content to help you study, students. We want to help you study and, clear every exam, do well in life. Okay. So when you do well in life, we want you all to remember us. That's the only thing we need. Yeah. Okay. So the equivalent focal length is 1 by F is equal to 1 by F1 plus 1 by F2 plus 1 by F. I'm just going a little fast with the derivations that we discussed yesterday. Okay. The ones that we didn't discuss yesterday, that I will do slowly. Like this one. This one we haven't discussed in yesterday's class. Derive an expression for refractive index Mhm. Yes, that's the most important thing, hacker. I'm earning that. So the only help you can do to all of us teachers is please do support us. Okay. Watch the video. Please ask your friends to subscribe and like the video. Okay. So we are able to continue to do this. Yes. Otherwise, the channel would not be able to move forward. Okay. Thank you, Hacker, for your support. So derive the expression for refractive index of the material of a prism in terms of angle of minimum deviation and angle of the prism. Okay. So let's look at the figure first. Let's look at the figure. So this is the incident ray. This is reflected like this, and then it goes on like this. Okay. It just comes on like this. Okay. So the incident ray, imagine if the prism was absent, then the incident ray would have just gone like this. Yeah. Okay. Now, even the refracted ray, if you extend it backwards, it comes on like this. So the total deviation is delta. Okay, the deviation from the actual path and the path that is actually there, that deviation is delta. Okay, if that is delta, then I can say this is delta 1 and this is delta 2. Yeah. Now, this will be R1 and R2. Okay. Thank you all. Thank you all for your support. Please do share this, channel with all your friends and tell them to subscribe and support us. Okay. Yeah. Have you all liked the video? Yes. Only 38 people have liked the video. Students, at least make it 50 likes. So it looks good, no? Some motivation. After 4 hours of class, when I go look at my class, I need some motivation. You guys don't write any comments. So there's no motivation there. At least like the video. Thank you, Rai School Gamer. Okay, so what will we do? I just hope Rai School Gamer will pass and pray that you pass. Okay. So what will we do? First thing is this. Okay. This angle is the same as this angle, which is A. Okay. So R1 plus R2 should be equal to angle A. Okay. R1 plus R2 should be equal to angle A. Now the total deviation D is, how do I get that? So how do I get that? This angle is I1 and this angle is actually del 1 plus R1. So I1 is equal to del 1 plus R1. So from that I would get del 1 is what? I1 minus R1. Yeah. So D is I1 minus R1 plus. Same thing you can do on this side. Okay. So this whole thing is I2 and this whole thing is del 2 plus R2. So what will it become? I2 is equal to del 2 plus R2. So del 2 is equal to I2 minus R2. So and then when you equate it, R1 plus R2 is A. So you will get D is equal to I1 plus I2 minus A. Okay. Yes. Now, if angle I is equal to I1 is equal to I2 and angle R is equal to R1 is equal to R2. Okay. Then what will we have? We will have 2R. R1 plus R2 is A. So this will become 2R is equal to A. From this we will get R is A by 2. Now what will this equation be? This will be D is equal to 2I minus A. So from this I will get I is equal to A plus dm by 2. Okay. Yes, hacker, I saw your like. Thank you. Go send it to all your friends, ask them to like, subscribe, and watch the video. Okay? So the formula is I is equal to A plus dm by 2 and R is equal to A by 2. Now I will substitute this in Snell's law. N is equal to sin I by sin R. Okay, what will I do? I will just substitute. What is I? I is sin A plus dm by 2 divided by sin A by 2. Okay, that is the final expression. Okay, for refractive index. Okay, let's look at the next question. Two coherent waves of at a constant phase difference undergo interference. Obtain the expression for the resultant displacement. So what should I do there? So first thing I will write down the formula. Y1 is equal to A sin omega t and Y2 is equal to A2 sin omega t plus phi. And then I will just add it. So what will Y be? Y would be Y1 plus Y2. And then what I will do? I will just use this formula. Sin A plus B is equal to sin A cos B plus cos A sin B. So when I keep adding, I will get A sin omega t plus A2 into, sin A plus B. So sin omega t cos phi plus cos omega t sin phi. Okay. Now what I'm going to do is I'm going to open all the brackets. Okay. So A1 sin omega t plus A2 sin omega t cos phi plus A2 cos omega t sin phi. I take all the important terms outside. What comes? A1 plus A2 cos phi sin omega t plus A2 sin phi cos omega t. Okay. So R cos theta will be A1 plus A2 cos phi. How did I get A1 plus A2 cos phi? I just take this part. Okay, this part I take it as R cos theta. And R sin theta I will take it as A2 sin phi. Okay, now the resultant displacement. What will the resultant displacement be? Y will be R cos theta sin omega t plus sin theta cos omega t. So y will be equal to R sin omega t plus theta. Okay. Similarly for amplitude, you just have to square the whole thing. You have to add equations 1 and 2 and square them. You will get R is equal to A1 square plus A2 square to A1 A2. Okay. Yes. Yathan ma'am, OP in the chart. What does that mean? Is that some of your Gen Z terms? Tan phi is what? A2 sin phi divided by A1 plus A2 cos phi. Okay. Next is the conditions for constructive and destructive interference. This also we've discussed in the last class. You just have to know the conditions. Okay. Yes, PDF I will send. Okay. Don't worry. What is photoelectric effect and write experimental observations of photoelectric effect? This question I have discussed yesterday, today, so many times. Okay. Now, if this was an offline class, I would have asked each one of you to tell me the answer because that many times I've discussed this. Okay. So what is it? It's a instantaneous process and the incident ray has to be greater than the threshold frequency. Only then electrons will be emitted. Okay. and whatever incident ray comes, some of the energy is used to emit the electron, the rest of the energy is used as kinetic energy. Okay? OP means overpowered. Okay. No, I'm a little older generation, no, so I didn't understand. I sent PDF in the Vedantu Karnataka Telegram channel. Okay, so go to Telegram, type Vedantu Karnataka, join the channel, you will get the notes. Okay, Rai School? So Rai School has to, pass. Only then he will recommend this channel to all his friends. Yes, Rai School. You can recommend the channel to all your friends before the exam so they can also pass, no? Okay, so all of you in all your groups, send these videos, tell them like, share and subscribe, tell them there is a teacher, that you should like, share and subscribe, okay? Deal? Yeah? Okay, next, write Einstein's photoelectric, okay, this also we discussed, but yeah. Write Einstein's photoelectric equation, use this and explain the experimental observations of photoelectric effect. Okay, so what is Einstein's photoelectric effect? E is equal to h nu. Einstein explained the photoelectric effect based on his theory called the Planck's quantum theory. You don't have to learn all that. So according to him, light consists of very small packets of energy called photons. Okay, and he proposed that photoelectric effect is because of collisions of photons. Okay, so photons collide and they hit metal atoms, they free electrons. The energy of each photon is given as E is equal to h nu. Okay, E is equal to h nu. Now Einstein's photoelectric equation can also be written as h nu is equal to phi naught plus k max. What is the meaning of that? An incident radiation comes, okay? The incident radiation has energy h nu, okay? So this hits, electrons and it knocks out an electron. So the energy required to knock out an electron is called phi naught. It is called the work function. The rest of the energy is stored as kinetic energy. Okay? Yes. So this can also be written as, sometimes phi naught can be written as kinetic energy is equal to h nu by phi naught. Phi naught can be written as h nu naught. Yes. What is h nu naught? H nu naught is the threshold frequency. It is the threshold frequency. So the equation becomes kinetic energy max is equal to h into nu minus nu naught. Okay. So you can read all of these experimental observations when I give you the PDF. Alright. Yes? No? Are you all tired? We still have to do numericals, not in this class. If I do numericals also in this class, I'll die. Okay, I need some break. So today night or tomorrow, I'll let you know. Okay, depending on my energy, I will do the numericals as well. Okay, yeah. So next question is, what is a rectifier? Explain the working of a PN junction diode as a full wave rectifier with circuit and input-output waveforms. Okay. So this also we've discussed. So what is a full wave rectifier? A full wave, full wave is this. A full wave rectifier is when you have an AC. What is a rectifier? A rectifier is something that converts AC signal into DC. Okay. So a full wave rectifier is where it has a full AC signal and then that is being converted into a DC signal, a full DC signal. Okay. So these are the input-output waveforms. Now, how does this happen? So a rectifier has diodes. Okay. A diode is a device that allows current to pass through only in one direction. So here you have two diodes. Okay. So the first diode allows current to pass through only during this positive half cycle. Okay. So you can see when this is how the graph is going to be. So when the positive half cycle is there, the diode conducts. Okay. And you will get an output. But at the negative half cycle, this diode D1, it does not conduct. Okay. It does not conduct. So there is no output at diode D1. Diode D1 does not work. Now, now what happens? There is a diode D2. So diode D2 does not conduct during the positive half cycle. So during the positive half cycle, diode D2 is off. During the positive half cycle, diode D1 is on. D2 is off. But during the negative half cycle, D1 is off, but we have D2 working. So you can see during the negative half cycle, this is the output. So at every half cycle, you have an output. Yeah, you have an output. That is because there are two diodes and the diodes continuously, alternatingly keep, what do I say? Conducting. Yeah, keep conducting for every half cycle. So for positive, D1 conduct, for all the negatives, D2 conduct. Now alternatingly, they produce a full DC waveform. So this is a full wave rectifier. Now what is a half wave rectifier? A half wave rectifier will have only one diode. So obviously you should be able to guess on what happens. Because it has only one diode, whenever the positive half cycle reaches the diode, there will be an output. But at the negative half cycle, there is no output. Because diode D, which is a single diode, works only for one direction of current, which is only the positive. That is why you can see this is the input. So whenever it is positive, you have an output. Okay. Whenever it is negative, you can see that it's a straight line. There is no output there. Again, positive, there is an output. Negative, there is no output. So now you have the output of a half wave rectifier. You have a hill, blank, hill, blank, hill, blank. All these blanks are because the negative half cycle won't be conducting because diode D can only conduct in one direction. Is this clear to all of you? Yes, no? Yeah, so this is the working of a half wave rectifier. So current exists only during the positive half of the input AC signal. In a half wave rectifier, a PN junction is connected the structure of a half wave rectifier, you have a PN junction diode. It is connected in series with a load resistance RL and is placed in the secondary circuit of a transformer. Okay. The primary of the transformer is connected to the AC supply that must be rectified. So you can see that here. This is a transformer. The primary is connected to the AC source and the secondary is connected to the diode and the structure, the rest of the structure. Okay. So during the positive half cycle, A is positive relative to B, the diode becomes forward biased. Okay. So during the positive half cycle, the diode is forward biased. The diode conducts electricity, allowing current to flow through RL. When A is negative, A is negative relative to B. So when A is positive, diode D will conduct. When A is negative, diode D will not conduct. I explained the same thing. So when the AC signal, when the positive part comes, diode D will conduct. When the negative part comes, diode D will not conduct. Okay. Ma'am, how to rectify question answer in one day? Sit and study. Okay, I hope what you meant is how to study all this in one day. You have to take a pen, paper, take the notes, sit and study. Write down each derivation at least 3 times. Okay, students, see, if you see the derivation and go for the exam, some of you might remember, but most of you will forget, okay? Because I was also a student like that, I used to forget. So, what I used to do is I used to write, okay? Every time I learn a derivation, I write it at least 3 times. Once I look at it and write, once I try to write it by myself, I make mistakes, and then once I write it again without looking. That's when I become thorough. Sometimes I have to write it 4 times as well. That's how you study derivations properly. Okay, so you study all the derivations properly, thoroughly. And as I said, MCQs, don't miss out on MCQs. There's a video on 100 plus MCQs. So after exam 2, many students came to me and they told me that they got 15 out of 15 for MCQs just by relying on that video. So let's just hope that for exam 3 also, that video becomes helpful because it's the same textbook. You can't have questions from anywhere else. So students, please go through that MCQs video and prepare for MCQs, prepare for 2 markers, 3 markers, 5 markers, numericals I will do. Okay, I have not done it yet. I will do one more video. But all of this content is out there on YouTube in Vedantu Karnataka for you. You just have to make use of it, students. Okay. See, Rice School, I don't know if the paper is going to be easy or not. Okay, because I'm not part of the paper putting committee or anything. But let's just hope it will be easy. Okay, so right now I don't want any of you to be tensed because this is the last minute. You don't have time to be tensed. So you just put it in your mind that if you study for 2 days, you will pass. Okay, and with that mind, you sit and study. Okay, you understand that? So don't worry. So whenever tension comes, you think that with whatever you have and whatever you're going to prepare, you will pass. Okay, so relax, keep yourself calm and believe that you will pass and sit and study. If you simply believe you won't pass, I want you all to sit and study. So don't worry. If you start worrying, then you will waste time. Okay, so just think that the exam is going to be easy and start preparing for that. Okay, I want all of you to do well. I've also put in a lot of work, You are also putting in a lot of work. So together, I just hope we pass and score very well. Okay. So after your exam, all of you should come and tell me in the comments how the exam was. Okay. I just want to hear that it was good. I just hope that it turns out to be good. Okay. Do you have any doubts? Otherwise, we can wind up the lesson. So I will see you with another video where I will be discussing numericals. Today or tomorrow, I'm not very sure. I'll tell you, let you know. Okay? Yes. Still scared? You can all do it. Okay? Relax. Don't waste time. Now itself, you go sit and study. Don't go roam around. You can go to your kitchen, have a cup of tea or coffee, go sit and study. Okay? Yes? All the best, my dear students. I will pray for all of you. Okay? Is there any rules? What rules do you mean? It's just like your exam 1 and exam 2, dear. It just has a different name, which is exam 3. That's all. Okay? Don't worry. You will all do well. Yeah? Bye-bye. I'll see you all in the next class. Tata. So send this video to all your friends. Let them also study. Okay? Yesterday's class also send it to all your friends.